Hello, everybody. You are listening to Through Time and Clades. My name is Albert.
And I'm Joan.
Yep. And today we are coming back to Dinosaurs, the second chapter. So, kind of my series on crown bird evolution. All right. It's been a while, but we're back at it. And today we're going to be covering a pretty large and diverse group. This is a group called Charadriiformes. Um, Colloquially known as the shorebirds. So I decided to name this episode "Living on the Edge" because they kind of live on the margins of two different, very different kinds of environments: the aquatic and terrestrial environments. Although, as we shall see, they are actually even more diverse in terms of their habits than just shore-dwelling species. There are some that live out in the open ocean, and there are others that live far inland, away from any kind of permanent water. So they are an extremely diverse bunch. But before we dive in, I guess tell me how's it going?
It's been pretty good. I've been working on general things here and there, but mostly been normal. As y'all know, the house move is still going on, and we're slowly inching towards that date when we you know close the house and move into the apartment for a little bit while we you know mom and dad construct their home. So that's been pretty good. But I've been keeping up with all sorts of things. Pop culture wise, I'm happy to say I was finally able to tune in online to the 2016 remake of Roots, which I was finally able to watch over a 4 night period, and that was excellent, very moving, and very well done.
Wow.
So I highly recommend any of our listeners who haven't seen it to go check it out. And I'll probably go and check out the original
Mm,
1977 version
right.
too, just so I can compare the two, because I think there's a lot of interesting. As I understand, there's a lot of interesting backstory with the original book,
Mm,
which the series, both series, are based off of by Alex Haley. Um,
right. I'm sure there is. Yeah.
but it's one of those cases of like it's like quasi historical fiction. Like it's very grounded in real events. But it is also like a story that's been constructed a little bit to kind
Right.
of give like a narrative flow to the different generations, um, which I think is brilliant. It's a brilliant idea. Um, in fact, I believe we have that book too. My folks had saved it from my late grandmother when we were um, moving out there. So I might have to go and read that too.
Wow. Mm.
Um, but otherwise, I've been really good. What about you, Albert?
Yeah, things have been pretty good over here too. I've been busy with a couple different research projects, kind of as always, I think. Um, but yeah, that's all progressing reasonably well, according to schedule, as far as I've planned at least. Um, so yeah, things are. I guess I'm staying on top of things for the time being, which is good.
Yeah, that's good to hear. Now, obviously, I guess before we jump right in,
Mm,
I believe one announcement deserves mentioning.
that's right.
At the time of recording, tomorrow, which is February 12th, is Darwin Day,
Yeah.
um, which celebrates the anniversary of Charles Darwin's birth in 1809. So he would be 212 years old today, which
Yeah.
is pretty good. But of course, the celebration really kind of commemorates Darwin's life in general. The anniversary of the Origin of Species publication, and among other things. And usually, like if you are part of like natural history communities or paleontology or evolution or what have you, you've certainly heard of Darwin Day and have
Mm,
probably participated or promoted various Darwin Day
right.
activities. Albert, I know that you've usually commemorated each day by singing the Charles Darwin song.
Yeah, Mr. Darwin. It's a yeah. There are actually a number of songs, or at least I know of a number of songs on Charles Darwin. But yeah, the one I particularly like is Mr. Darwin by David Haynes, which talks a little bit about just Darwin's life and his discovery and eventual presentation of the theory of natural selection, and also also mentions other people who independently came up with the idea around the same time.
Yeah, it's pretty cool.
Mm, mm,
I don't know what I'm going to do tomorrow to celebrate. Maybe I'll go back and rewatch some Darwin themed media.
mm,
There's a couple movies that I've seen. Darwin's Darkest Hour was really nice.
mm, mm.
Of course, there was also the mini series, The Voyage of Charles Darwin, which talks about the Beagle and Darwin's relationship with the crew there and everything, and his trip to the Galapagos and across South America, which usually is which is it's always funny to me. Like that's usually like the big highlight of whenever like the Beagle story is told, like the
Mm.
South America adventures. But like I think a lot of us forget that like he traveled across the Pacific too.
Right.
He writes extensively in his notes about his adventures in Australia
Hmm.
and
Yeah.
Tahiti, and I think he went to New Zealand.
Yeah, I think so. Yeah.
But I think probably the reason why those aren't mentioned as much, certainly among other reasons, was that by the time they had reached the Pacific, I think they were just tired.
Right.
Darwin, when that was younger, Darwin was like, I just want to go home.
Right.
It's been
Right.
5 years. I miss my family. Um, so it's like the excitement of Galapagos. Whoa, look at all these animals, and to platypus. That's cool. John, I want to go back home and sit in my comfy chair and quit being seasick for days on end.
Yeah, right, yeah. He wasn't a big fan of boats.
Right. I'm reminded of Ethan Kosak's comic, the very brief little it's Darwin and he's there on the boat and it's like, oh, here we see Charles Darwin, the great naturalist, on a voyage of discovery, and he just vomits over the side of the boat. I'm paraphrasing, I'm sure, but
Right, right. That's pretty
that
funny.
cracked me up when I first saw that. But yeah, so I thought it'd be good to bring that up.
Yeah, definitely, for sure. And if you
I know,
hadn't, I
but
would have.
yeah. I know by the time this episode would air, like Darwin Day will be done.
Right.
But definitely, like if any of you are listening, like feel free to leave in the comments. What do you do for Darwin Day? How do you
Mm.
celebrate? Do you do anything at all? Darwin facts that you're interested in?
Mm.
Yeah, just share with us. It'd be fun to hear.
Yeah, indeed, indeed.
Incidentally, it's also February 12th is also Abraham Lincoln's
That's
birthday,
right. Yep.
which is yeah, that's an interesting kind of coincidence there. It's like two big names in human history
Hmm. Indeed.
share the same birthday, which
Right. Yeah, and I think although not as big of a name in kind of general human history, I believe it is also the birthday of Barnum Brown, who was the man who discovered Tyrannosaurus Rex.
oh really? I didn't know that.
Yeah.
Yeah, that's right, 1873. Oh, that's incredible. Wow.
So yeah, quite a few notable figures were born on that day.
Right. Wow, how about that? I'm sure there's others we're probably
Oh,
missing,
of
but
course, yeah. But yeah, definitely in terms of overall fame and being adjacent to our interests, I think those people are some of the most notable ones.
absolutely. Well, that's cool. That's awesome.
Dude, happy well, from our perspective at the time of recording, happy early Darwin Day, but by the time you're listening to this, happy late Darwin Day. Um, Now, as far as I can remember, I don't think Darwin wrote very much on shorebirds that I'm aware of. But there are a lot of very interesting evolutionary stories within shorebirds. Definitely a lot of interesting things about their beak shape and different adaptations to different foods. So I'm sure Darwin would have been interested in them if he learned about their evolution, which we will be talking about today.
Yeah, sounds exciting.
And I'm sure that you're pretty excited about this episode too, because of course your avatar on the show is a charadriiform. You are a killdeer or a type of plover, so they are a member of this group, as I'm sure you know.
Yeah, absolutely. A little bit of spotlight on one of my favorite birds.
Right, yeah. So we will be meeting plovers today and all of their close relatives too. So yeah, I suppose do you have anything else to add before we get started?
Nope. Let's dive right in.
Cool, cool. All right. So next slide, we'll introduce the group Charadriiformes. So again, colloquially known often as shorebirds, although not all of them are shore-dwelling. Now, in terms of their fossil record, as we shall see, they don't have a particularly good fossil record overall. In particular, their Paleogene record is quite spotty, so we do not have a lot of definite Paleogene shorebird fossils. Um, we do have a few from the Eocene, so their known time ranges from the Eocene to the present, but overall, it's kind of a sparse fossil record with some exceptions, as we shall see. Now, if you have, I don't know, if you've read somewhat deeply into, fossil bird literature or just Mesozoic literature, um, you might have heard the idea that there were shorebirds in the Cretaceous. Ooh, living alongside the non-bird dinosaurs, and you can actually find paleo art of this quite often. If you put in a few kind of shorebirds in as kind of background dressing in Cretaceous scenes, somewhat inspired by this idea. We'll get to that towards the end. Like, were there really Cretaceous shorebirds? Well, I'll say that there aren't any. I would say fossils that we can definitely say yes, this is a shorebird. We can really confidently say this is a shorebird from the Cretaceous. But there are reasons why people have suggested that there were Cretaceous shorebirds. So we'll come back to that. There are over 300 living species of shorebirds, so that's quite a few. And as you might guess from the fact that their common name is shorebird, they often forage near water, but again, not always. And most of the time, they're carnivorous. We'll meet some exceptions to that as well. But a lot of the time, their prey is often pretty small things. So, tiny worms, other types of invertebrates, tiny arthropods they can catch in the water or in the soil or in the sand. So, they're often feeding on animals, but animals that are much, much smaller than themselves. But we'll see exceptions to that too. This is a group full of exceptions, as we shall see. Now, to help catch these tiny animals, a lot of them have a very, very flexible bill. And we've talked before about how a lot of modern birds have flexible skulls in general. Like pretty much, or almost all crowned birds have a skull that is, in many ways, more flexible than ours. So, in our skull, there's basically only one movable joint, right? So that's the jaw joint in the back of the skull that opens and closes the mouth. In crowned birds, as we've spoken of before, there, in addition to the jaw joint, there are a number of other joints in the skull that can be moved, and one of these is often where the base of the bill meets the rest of the skull. That part is often a bit flexible, so birds can often flex their upper jaw kind of up and down independently of the rest of the skull. And in shorebirds in particular, there is often also some bending zones, not just at the base of the bill, but also along the length of the bill as well. So a lot of different shorebirds, they can actually kind of flip their bill kind of upward, not just at the base of the bill, but like halfway down its length, they can just kind of flip the tip of their bill up if they want to. And that can be useful for a number of different reasons. So, for one, you can grab something really small with it because you can also bend the tip of your bill down to kind of clamp onto something. So that's useful for grabbing little things. Something else that helps them do is that if your bill is kind of buried in the sand or the soil, a lot of shorebirds feed by sticking their beaks into the ground below them. You can open just the tip of your bill, even if your bill is mostly stuck in the ground. You can just open the tip of your bill to grab something if you come across something you want to grab. And something else people have observed is that this kind of bill flexibility helps them grab things from the water. So a shorebird can stand, in shallow water or by the side edge of the water, and look for very small animals that it wants to eat, and then if it wants to catch something, it can open just the tip of its bill and plunge its face in to grab the prey item. Now, why this is useful? Well, if you open your bill from the base, you end up with a very wide gape, right? So if you thrust your face into the water, you get met with a bit more resistance than you would if you just opened the kind of little tip of your bill, forming just a little narrow surface to grab something. So that's kind of a useful adaptation there. So definitely, they have a lot of interesting ways of getting their food. Now, typically, shorebirds nest on the ground, though again, not always, and oftentimes they have precocial or semi-precocial young, and we have, I believe, introduced these terms before. So a precocial animal is one that hatches out or is born basically ready to go. It can run, it can walk, it can usually feed itself. So if it has any parental care at all, it's pretty much limited to the parent kind of leading them around to safe places or defending them from predators. But otherwise, they're pretty self-sufficient. And semi-precocial young is a term that's mostly applied to birds. So this describes when baby birds hatch. They are able to run and do all of that, but they might still spend some time being fed by a parent, maybe even staying in a nest for a period of time. But they are not completely helpless, unlike fully what we say altricial birds are, where they're in altricial birds, the babies might be born blind and basically unable to walk with like these huge, proportionately huge heads that they basically drag around on the ground. Or against the bottom of the nest, as the case might be. So, yeah, baby shorebirds, they're born nice and fluffy and ready to go, which is pictured here, which is why I picked this picture of a baby plover. Baby shorebirds tend to be very cute because nice and fluffy. They're hatched like bright-eyed and bushy-tailed and ready to go. They can run. Now, in terms of some of their skeletal features that can help distinguish them from other birds, shorebirds often have these large depressions in the sides of their back vertebrae. This feature has been found in a number of fossil bird groups, but it's pretty rare in living bird groups. It's mostly the shorebirds that have them. The hallux, which we've also spoken of before, that's the innermost toe in birds, which is usually pointing backwards in a modern bird, is often highly reduced in charadriiforms, and many of them have lost the hallux completely. So what this means is that they usually can't use their feet to grab onto things very well. You won't see many shorebirds spend a lot of time in the trees, like perched up in the branches or whatever, although a few of them do. As always, exceptions are everywhere. And they have or rather they don't have an air sac opening in the humerus, which most other crown birds have. So in most crown birds, the humerus, which is the upper arm bone, has this hole in it for air sacs to fit into. But in shorebirds, this opening is lost, so they don't have it. Now, if you have a good memory, you might remember that this is also the case in the ralloid gruiforms, so the rails and their relatives, which we talked about in the previous episode. So little bit of possibly convergence there, depending on how charadriiforms and gruiforms are related, which again we're not sure about because neo-avian phylogeny is a mess. But yeah, it has been a rather popular hypothesis for a long time that charadriiforms and gruiforms might be closely related. Well, we'll see how that plays out, but there is some evidence for it, definitely. Okay, so yeah, that's charadriiforms in general. Do you have anything to add?
Nope.
Alrighty. So, I guess we can get more specific now on the next slide. So, I guess the basic thing you need to know about charadriiform phylogeny is that you can basically split them into three major groups. So, there's the charadri, which are the plover-like shorebirds. And then the Scolopaci, which we'll meet later, the sandpiper-like shorebirds. And then the Lari, which are the gull-like shorebirds. And we will get to each of these groups in turn, but we'll start out with the plover like charadri. Now, the charadri in particular, I said that I said that shorebirds in general don't have a very good fossil record, but I guess unfortunately, Charadri in particular have a very poor fossil record. Um, I mean, we do have some. We have bits and pieces, mostly of various different groups of them. But yeah, not a whole lot that's particularly complete or especially informative about how they diversified or what their ancestral form was like, things like that. So yeah, not much we can say about their fossil record, but we will be seeing a few fossils in this section. So their known time ranges from the Oligocene to the Holocene. As you can see, that's relatively late. Like there's nothing that we know of from the Paleocene or Eocene that definitely belongs to this group, though there might be some. Um, Over 100 living species, so I guess roughly a third of charadriiform diversity. I guess the three different clades, the major clades I mentioned, they're divided relatively evenly in terms of their species diversity, so that's kind of convenient.
Hmm.
And just to mention one of their osteological or skeletal similarities that's shared within this group. So we're looking again at the hypotarsus. If you've followed the series from the beginning, we've mentioned this structure quite a few times. So this is a little ridge or bump at the base of the foot in crown birds, base of the tarsometatarsus. So those are the ankle and foot bones fused together. And so in the figure over here, we're looking at the left foot, but you're looking at it at the base, so where the ankle would be joining with the lower leg, basically. So you're looking at the joint surface there. And from the bottom of the foot, you can see projecting out the little bump there. That's the hypotarsus, which often has various canals or furrows for tendons of the foot to pass through. And in the members of Charadri, one of the deep tendons of the foot, or the canal for that tendon, is shifted to one side. So that would be the canal that's labeled as a FDL in this figure. And in the members of Charadri, which are in the bottom row here, and I've labeled with this red box, the FDL is kind of shifted to one side so that it is not in line with the canal for that is labeled PP2, which is one of the tendons that flexes the second toe of the foot. So you can see that in the other members of charadriiforms, these two canals or furrows are closely aligned to each other in the same plane, but in the members of Charadri, the canal for the deep tendons are shifted to the side. Does that make sense?
Yeah.
Yeah, and you can see the kind of the dashed line and the dotted lines on the figure kind of showing this. Right. So that's a bit arcane, but I just wanted to bring that up so you can see that there have been some features identified of this group. Okay, so let's go in and look at the various living groups of Charadrians. All right. So there are a number of different groups. I think in a way you can think of all these different groups as different ways of being a plover, but in general, only one of the groups are considered the true plovers, I guess you could say. So we'll get to them last. But first, let's look at some of their close relatives. So first up, we have a group called the Magellanic plovers, which is only known from one living species from the southern tip of South America. And this species, it breeds along freshwater and brackish lakes, but it moves to the coasts in the winter. And it is called a plover, but it feeds in a quite a distinctive manner, or rather, it feeds in a quite different manner from the true plovers. So I'm sure you are aware of this if you've observed plovers for any length of time, but plovers are a very distinctive kind of foraging style where they'll take little runs and then suddenly stop, and then if they see another food item, they'll kind of take a short run towards it, grab it, and then they'll stop again and kind of look around for danger. Have you seen this?
Oh yeah.
Yeah, right.
Almost 50.
Yeah. They do it all the time. Yeah, the Magellanic plover is a lot more methodical and deliberate in terms of its foraging behavior. It kind of walks around slowly and kind of pecks repeatedly at the ground, and they also dig for prey too. Like apparently they'll sometimes dig like a little depression in the ground that's so big they can fit their entire bodies in there. So, yeah, quite different in terms of behavior from the true plovers. But yeah, that's the Magellanic plover. It is closely related to, I believe, the next group. Yeah, the sheathbills, which are a group that you might not be all that familiar with. There are two living species, and they're found mostly in Antarctica and the subantarctic islands. And one of the species, it will migrate to southern South America when it's not breeding um, as well. Now, the sheathbills, they're pretty interesting because they're very opportunistic feeders. They do not spend a lot of time in the water. In fact, they even though they can swim, they generally avoid water if they can help it. What they'll do is they'll kind of walk around on the beach or any place where there might potentially be scraps of food, and they'll eat pretty much anything they can find. So they'll eat algae from tide pools, they'll eat various different kinds of invertebrates, they'll scavenge from carcasses, and they will feed on the eggs and chicks of other seabirds. But they'll eat some other things too. So, for example, where they hang out on the shorelines of Antarctica, there are often a lot of penguins and seals also breeding there in the summer, right? So what they'll do is they'll actually steal food regurgitated by penguins. So because the penguins are trying to feed their chicks, right? So when the penguins are getting ready to feed their chicks, the sheathbill will suddenly move in and grab the regurgitated food right out of their mouth.
Oh,
Um, and they'll eat other things that penguins and seals leave behind. They'll eat the afterbirth from seal placentas. They'll eat feces from these other animals. They'll even steal seal milk when they can get it. So yeah, anything that's remotely edible, a sheathbill will eat it. So I, I think they've been described as kind of the garbage crew of the Antarctic because yeah, they're just stalking around and kind of eating anything possible they can possibly find.
what a life.
Yeah, indeed. And their breeding period often coincides with that of penguins, and you might be able to imagine why that is. And this is so they can maximize kind of the amount of food they can get to feed to their own chicks. So yes, that's going to be when there are going to be penguin eggs available for them to steal, and after the eggs hatch, the penguins will be feeding their young, and so they can steal food from the penguins that are doing that. So yeah, quite an interesting bunch, and they're like the only Antarctic birds that are basically terrestrial, I think. Um, so again, they are able to swim, but they prefer not to. So they spend pretty much all their time on land. I guess strictly speaking, they still feed from the marine ecosystem because they depend so much on kind of the leftovers from penguins and seals. But yeah, they basically kind of land dwelling existence on Antarctica, which is pretty rare for a vertebrate. Now, the sheathbills and the Magellanic plover, they form a group within Charadri, and we don't have any definite members of the sheathbill or Magellanic plover lineages that have been identified in the fossil record yet. But on the next slide, I'm showing a number of fossils that probably belong to a lineage uniting both of these groups. So these are the Chianoids, both the sheathbill and the Magellanic plovers. Um, Now, as you can see, these fossils are pretty scrappy. So both of these are the coracoid. So in the case of the one on the right, it's a piece of the coracoid, so not even a whole bone. Um, but the coracoid is a bone in the shoulder girdle in birds and in most other land vertebrates, though mammals don't have it anymore, or rather, placental mammals don't have it anymore, so we don't have one. But yeah, the Chianoides from the Oligocene of Australia is known from a basically complete coracoid. Neoliths from the Miocene of New Zealand is known from this piece of coracoid, but also a few other bones that might belong to it. So yeah, we don't know too much about what they look like. We can tell that they're much smaller than sheathbills, which are around the size of I don't know a small chicken maybe. Um, but so they're more in the plover size range. But we don't really know much about what they look like or how they lived or anything like that. And something else interesting is that they were found in places where we don't find members of these lineages today. They were found in Australia and New Zealand, where we don't find sheathbills or the Magellanic plover. So we can see that they once had a much wider distribution in the past. Other than that, these guys are pretty scrappy. Um, Now, in turn, the cyanoids are closely related to a third group, which is a group on the next slide. This group I've called the dickups, but actually that's not their most common name. So they have a couple of different common names. One of these is the stone curlews,
Mm.
which is a bit misleading because they're not curlews. Curlews are shorebirds, but they're a type of sandpiper, so they are not closely related to this group. So yeah, this group is also called the stone curlews. Another name for them is the thick knees, um, and they're named this because kind of the main joint in their hind limb, or the main visible joint in their hind limb, is a little bit thicker than you would expect from other shorebirds. Now, that particular joint you see in the hind limb, as you are probably aware if you're listening to this, is actually the ankle joint in birds. That main joint kind of somewhat visible on the hind limb there, not the knee joint, which is usually held very close to the body in modern birds, and typically covered in feathers, so it's not really visible. So both of those names are a little bit misleading in different ways. So I like to use the name dickups for them, which is a third common name for them, although it's not as commonly used. But yeah, the dickups are found on pretty much every continent on Earth except for Antarctica. Now, if you look through field guides for North American birds, you usually won't find them, and that's because they don't get up north of Mexico most of the time, and most North American field guides are limited to kind of the United States and Canada.
Mm.
But they do get up, into Central America, so they can be found on all the continents. Well, again, except for Antarctica. So a much wider distribution than their close relatives, the sheepbows and the Magellanic plover. There are 10 living species, and these are one of the groups of shorebirds that don't always live on shorelines. Um, in fact, you can sometimes find them in quite arid habitats far inland. So yeah, they're definitely not tied to shores. Something else interesting about them is that they are nocturnal, or at least they forage at night. And you might be able to see in the picture here, their eyes are pretty big, um, and that's because they are nocturnal. Now, that doesn't mean they just sleep around all day. I actually got to see wild dickups when I was at SVP, or Society of Vertebrate Paleontology annual meeting in Australia in 2019. Um, so there's a species there called the bush thickney, which is reasonably common. You can find them in city parks and places like that. And oftentimes, even though it's the middle of the day, I'd see them wide awake. But they wouldn't be very active most of the time. I saw one kind of walking around in front of a visitor center at a wildlife sanctuary, but I think that was the most active one I saw. Most of the time, they're kind of just sitting there, like in the shade of a tree, or yeah, just chilling, kind of, um, and not doing a whole lot. But they were very very much wide awake. Um, but yeah, it is really at night that they do most of their actual feeding. And in terms of food, like most other shorebirds, they like to eat kind of small invertebrates and things mostly. Um, but in their case, it doesn't have to be aquatic prey. They're plenty. They can subsist plenty well on kind of land dwelling prey as well. Yeah. Do you have anything to add about this group or these past couple of groups?
I was going to ask, is decop like a local word or like an
Yeah,
indigenous
yeah,
name?
I believe so. Yeah, I think it comes from Afrikaans, I think.
Oh, gotcha.
Yeah, yeah,
Okay.
yeah. So it is in fact one of the African species, the water dickup that I've pictured here, that often is used, or rather, that common name is often used for. Um, but yeah, most of the others they tend to be called thick knees or stone curlews. So yeah. Mhm.
Right. No, I think it's a great idea to kind of like help distinguish like these particular animals that have been named despite biology
Mhm.
by giving them like more like giving their like local names more presence in the literature. Kind of like
Right.
how we try to refer to elephant shrews as sengis
Mhm.
nowadays. Which I think
Right.
is
Yeah, yeah, I agree. I agree. Like, I mean, we've had or at least mentioned this before. Like, yeah, it's true. Like, common names don't have to reflect biology, and not lots of them don't, and that's fine. But I think in cases like this, if there is a suitable, like, unique kind of local name, I think we should use it, right?
Yeah.
If there's already an existing name like that's in use for them, why not? Like, if it also helps um, emphasize their distinctiveness relative to a name that might give us an inaccurate sense of their relationships or biology. Yeah, let's go with a unique name that doesn't have to lean too far on other words to be meaningful.
Right, right. Because yeah, like I know, like like common names. Right, I agree about the common names thing for sure. I know, like when talking with non-specialists, like there can be confusion,
Mm.
which I think we could help mitigate that by
Right, right,
like switching to these sorts of names. Because like I've had like conversations like daddy long leg spider, right?
right,
Like, oh, that's one of those daddy long legs, and like, oh, they're actually not like true spiders.
mm.
They actually belong to their own group, and like,
Right,
oh, they're not spiders. What are they? Right?
right, right.
Like, I could kind of clear some of that up a bit.
Indeed, indeed. Yeah, so yeah, that's why I like to use the word dickups. Although most of the major ornithological societies don't seem to have adopted that yet. But yeah, the nice thing about common names is that you can kind of use what you like.
That's true, and I mean they do change over
They do,
time.
yeah.
Like who knows? Maybe someday in the future, like Dickup will be in all the field guides.
Right, right, yeah. All right, now we still have a few other groups of Charadri left to go, so let's keep going. Um, All right, here's one called the Egyptian plovers. Uh, Now, this is another group that's only known from one living species that's found in Central Africa. Now, it used to be found in Egypt in historical times, but no longer is. Probably because of the aridification that's gone on in the Sahara Desert. So this is a species that does kind of live on like riverbanks and places like that. Very kind of interesting kind of behavior that they practice is that they will bury their eggs and also their chicks under sand to hide them from predators and also to protect them from the searing heat. Yeah, which is quite interesting. And basically, when it's too hot, they'll bury their babies under the sand and they'll actually carry water over and kind of wet the sand in that area so the babies can keep cool that way. Yeah, quite interesting. Now, if you have heard of Egyptian plovers in like popular media at all, you probably know them as the bird that cleans crocodile teeth.
Uh,
Unfortunately, there are no confirmed records of this behavior actually happening. And if you've seen photos or videos of this happening, those are either photoshopped or CGI. Um, so yeah, there are basically no confirmed records of this behavior actually happening, which doesn't mean it doesn't happen. But yeah, no one has been able to actually reputably record or record this kind of behavior.
wow. Yeah, no,
Yeah.
I've definitely seen this in a lot of older books that I have.
Mm-hmm.
Especially as illustrations too.
Yes. Yes.
Like it's iconic almost.
Right.
So it's plain to me that it's not that we haven't like actually documented this happening
Right. Right.
in the literature,
Indeed. Indeed.
which kind of
Yeah.
makes you wonder like, where on earth did it come from?
Yeah, I know. I know. Like the very original, or at least that we know of, like in terms of like recorded accounts. Um, the original claims seem to have come from the ancient Greeks, where they talked about there are these birds that will clean crocodile teeth or pick food out of crocodile mouths, things like that. Um,
Oh, okay. That sounds like a. Oh my gosh, yeah. I think that's Aristotle.
Might be,
That's
yeah.
that's one of his animal encyclopedia things that I just
Right.
passed down over the ages.
Right, right. And they give the bird a name, Trochilus, which incidentally has been co-opted as the genus name of a group of hummingbirds. So the genus Trochilus is now hummingbirds, which do not come into contact with Nile crocodiles. But it has often been um, kind of assumed or speculated that the Egyptian plover was one of these birds that they were referring to in those accounts, and so that's probably where this kind of idea got started.
Hmm.
Yeah, but yeah, again, no one has been able to actually reliably confirm that this actually happens. So yeah, who knows? Maybe we'll find out that they actually do this someday. But for now, it is conjecture, I suppose.
Gotcha.
All right, let's see. The next group up here are the stilts. So, as you might be able to guess from their name, these are a very long-legged group of Charadriians. So, the other ones we just saw, they have relatively short hind limbs. So they're plovers are relatively short for charadriiforms, and most of them are kind of built like that. But the stilts are really on stilts. They have very long hind limbs, and they use these hind limbs to kind of wade deep into the water, and they'll use their bills to pick tiny prey items off the water surface. So usually tiny arthropods that are swimming in the water surface or floating in the water surface, and they'll kind of pick these arthropods off from the water surface with their kind of long and narrow bills. And one particular group of stilts is the avocets, with which I've pictured one of them here, and this group has a very unusual bill shape where you can see in the picture here that the tip of the bill is slightly upturned. And they feed in a way that's kind of different from pretty much all other birds. What they'll do is they'll lower their head to the water and kind of with the upturned bill tip in the water, and they'll sweep their heads from side to side, and in that way they can kind of grab all the little prey items that are floating up in the water close to the surface there. And they'll often nest in colonies, which is a habit of a lot of other shorebirds as well. So they'll nest in these big colonies where it's hopefully safe from predators, and I know avocets at least can be pretty aggressive during the breeding season towards other types of birds. If any other kind of bird shows up, like even if it's something that's relatively harmless, they'll quickly chase it off. So yeah, I know. Apparently, avocets have a reputation among British birders for kind of driving away all the other shorebirds from the area. So you're like, oh, you see an avocet, you're not going to see anything else, basically. And like, yeah, because of their very defensive nest guarding behavior. As I've kind of alluded to, by the fact that they can be seen around here, they can be seen pretty much worldwide, and where there's suitable habitat for them. They can be found on all the continents except for Antarctica. I know there is an American avocet species, but I personally never seen them before. I think, have you?
Yeah, me neither.
Yeah,
Trying to
yeah.
think of all my beach trips that I've taken, and it's not ringing a bell.
Right. Yeah, yeah. They're not. They tend to be found in kind of brackish water environments where it's kind of relatively deep for them to wade in, but not too deep. So yeah, they do have a certain kind of habitat preference that they like. So yeah, they're not a group that you're likely to see just about anywhere. Um, although they are pretty good swimmers, though. I know avocets they will actually swim out to relatively deep waters using their partially webbed feet, and kind of continue to feed in the same manner as described before. So yeah, in fact, pretty much all the shorebirds are pretty good swimmers if they have to be. Even though most of them spend most of their time foraging on the shoreline, they are able to swim. Like even as babies, people have observed like little baby shorebirds. If they're in danger, they often jump into the water and swim away from predators. Um,
Oh wow.
yeah, yeah, and some of the adult shorebirds will do this too. If you've seen the BBC series The Hunt, which is one of my favorite natural history documentaries of all time,
Mhm.
in their coasts episode, they actually show a flock of sandpipers being hunted by a falcon, and so the peregrine falcon dives at them, and they all take off into the air and kind of form this big swirling flock to make it very difficult for the falcon to pick out individuals. Now, eventually, when the falcon does isolate one of them, it actually the sandpiper actually plunges into the ocean to escape from the falcon, because the falcon can't afford to get its feathers wet, whereas the shorebird has much better waterproofing of its feathers, so it plunges into the water and gets away. Um, so yeah, that's one of the few times I've seen that behavior filmed, which is quite interesting. Um, but yeah, in any case, those are the stilts. We can continue to the next group. The next group is another obscure group with only one species. This is the ibisbill of Central Asia and the Himalayas. It lives mostly high up in the plateaus of these regions. And what it does is that it feeds in mountain streams. It doesn't like to fly very much, so it'll actually prefer to swim from bank to bank as it forages. And what it does is you can see that it has this very long down curved bill, and that's why it's called an ibis bill, but it looks like the bill of an ibis. Now, ibises are not shorebirds, so they're not closely related to the ibis bill. It's an example of convergent evolution. But what they do is that they'll use the ibis bills, that is, they'll use this down curved bill to find prey under rocks in stream beds. So they'll kind of use it to kind of poke underneath rocks and feel around for what's down there and grab little arthropods or a small fish to eat. And that's basically how they live. And ibis bills are very difficult to observe. They're pretty obscure for a reason, because you can maybe kind of tell from the photo here. Like, they have this kind of gray kind of plumage, and that makes them very difficult to pick out from the rocks in their kind of mountain habitat. So yeah, they're not an easy bird to see, even if you're in the kind of right range for them, which is already relatively restricted as it is. So yeah, definitely a very interesting species, and one that we don't know all that much about.
Yeah, I love their little horseshoe
Yeah,
um, coloration there. That's neat.
it is, right? Yeah, yeah. What is it for? I don't know. But yeah, I do like the color patterns. It is really striking and distinctive, and yet apparently is very good for camouflage at the same time. So yeah,
Right.
well done. And the ibisbill is closely related to another group called the oystercatchers on the next slide. Um, Now, the oystercatchers are known from the coasts of pretty much all the continents except for Antarctica. And yeah, again, they're mostly found on the coast, but sometimes they'll nest inland. Now, as their name suggests, they do eat oysters. It's not necessarily, the bulk of their diet, but they are specialized for feeding on bivalves, so all kinds of clams and their relatives, mollusks with two shells. Now, what's very interesting about the feeding behavior of oyster catchers is that it varies between different populations. Some oyster catchers feed primarily on worms, and what they'll do is use their bills to kind of poke deep into the soil to grab worms and then, pull them out. Others prefer to feed on bivalves, and they have two different ways of opening bivalve shells. So one way is that they will kind of wedge their bill through kind of the gap between the two shells, and then they'll try to slice apart the muscle that keeps the shell closed. And of course, once they do this, the shell pops open and they can eat the nice fleshy bit inside. But other oyster catchers have a different way of opening shells, and what they'll do is they'll actually kind of vibrate their beak against the shell and then kind of eventually hammer open the shell directly, so just smashing it apart. So yeah, three kind of main ways of feeding, and these types of feeding have a profound kind of influence on the beak shape of oyster catchers. So the ones that feed on worms, that stick their beaks into the ground for worms, have the sharpest and thinnest bills. The ones that feed on bivalves have a bit more chisel-shaped bills, as you might expect, so they can kind of get into the shells. But the ones that wedge their bill in between to slice the muscle, they have a thinner bill than the ones that hammer the shell open. Now, what's especially cool about this is that people have done experiments where they force the oyster catchers to switch diets from what they originally might have specialized in. And when this happens, the bill will actually change shape uh, in accordance with the new diet, and it can do this in a matter of weeks. So a bird with a dull shell smashing bill can get a worm probing bill, a sharp worm probing bill in a couple weeks or something like that, just by continuously feeding on worms instead of bivalves. And they can do this because a bird's beak is covered in keratin, the same material as our fingernails. So the keratin is continually kind of replaced, and it grows over time. And so in the case of the oyster catchers, it grows so quickly that the shape can be modified as the oyster catcher changes its behavior as needed. Um, so that's a really cool fact about oyster catchers. And it probably helps them out in nature too, not just in lab experiments. So if oyster catchers, a lot of them are migratory. So if they migrate to a place where they need to adapt to a different type of food source, they can quickly be able to do that, and they're not just stuck doing one kind of thing.
That's so cool.
Yeah. So oyster catchers, I've seen them here sometimes in mostly in kind of wetland bird sanctuaries. Yeah, they would sometimes nest out in the grassy areas. Um, at least the species that is found over here in England does. So yeah, have you seen them around?
I think maybe once or
Right.
twice. They're
Yeah.
kind of distinct, so you really don't miss them.
Right. Exactly. Yeah. Yeah.
Like when I was on trips down south to Florida, I
Mhm.
think I've seen some on like beaches and
Right.
somewhere. Not
Yeah.
often.
Yeah. Yeah. That would make sense. I'd expect to see them in those circumstances, but yeah, indeed, they are highly distinctive. You can't really miss them. They are quite large for plover-like birds as well. So yeah, they definitely not easy to miss. All right, let's see. Next group, we get to the true plovers, and the true plovers come in over 60 living species. So there are more of them than there are of the non-plover, like the non-plover charadriians. Um, and they can be found worldwide, again, except for Antarctica. And they are, so incredibly diverse that you can find them in pretty much any kind of open habitat. Now they do like open habitats, so you won't find them much in forests or places like that. But any place that is open enough, grasslands, even deserts in some cases, you can probably find some species of plover there. We mentioned before that they have this very distinct kind of run and pause foraging behavior. Yeah, so take a short run towards a food item. They forage mostly by sight, so they'll look around for something good to eat on the ground, and they'll run towards it, grab it, and then they'll stop suddenly and then kind of look around, see if there's danger, and then they'll repeat the action again. So that's a very distinctive kind of behavior that they have. Now, living in these open habitats, they kind of run into the trouble of keeping their babies safe because they nest on the ground out in these really exposed regions. So, what's a small shorebird to do? Um, well, first of all, there's camouflage. The eggs and chicks of plovers are often very well camouflaged, and there are some really striking photos of this out there. So you can Google like plover chick or plover baby or something, and you can find some incredibly um, well camouflaged examples. There are some that look just like the lichen on the ground you would find in like the Arctic tundra, for example. Um, so they are pretty good at hiding. Um, and the parents often engage in several different types of displays to protect their babies as well. A very well known one is, of course, the pretending to be hurt, feigning injury, the broken wing display. Now, this is very well known in killdeer, as I'm sure you know.
Oh yeah, I've seen this
Oh,
multiple
yeah?
times. When me and Dad would have to do yard work, and when they were actively nesting in our yard, you can't really escape that sort of thing.
Right.
Because we would always be mindful of the nests whenever we'd be mowing the lawn or whatever. But whenever we'd like just get a little bit close to the nest,
Yeah.
because we had to pick up branches or whatever, there'd be the mom or the dad in the background there, kind of folding their wings and doing the
Yeah.
beep 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 beep.
Right,
We'd be
right.
like, "Don't worry, we're not gonna mess with your babies."
Right, right. Yep, they do that. And I guess for those of you who aren't familiar with this display, that's when a parent bird pretends to be injured. So they'll kind of flop around on the ground, pretending to have a broken wing, and run, kind of pretending to struggle, and then hopefully that catches the attention of a predator that they're trying to distract. The predator follows them, uh, you know, preferably away from the nest, and then eventually. When they get far enough, the parent will suddenly magically heal itself and say, "Ha, tricked you," and then fly away. Um, and then you would have quite a heck of a time trying to find the well-camouflaged nest again. Um, yeah, quite a number of different birds from many different distantly related groups do this, but it's very well developed in plovers, and they have a number of other displays too, depending on the situation that they might use. Um, but that's definitely one of the most dramatic and well-known examples. Now, some of the larger plover species, especially the ones that are called lapwings, um, they will not just kind of distract predators, but also directly attack them too. Um, there are a number of species of lapwings that actually have these spurs growing out of their wrist joint in the wing. We've talked before about various crown birds that have spurs or spikes on their wings, especially the screamers, which are relatives of ducks. Um, so as you are probably aware, most crown birds don't have very well developed wing claws, unlike a lot of their close Mesozoic relatives. Now, a lot of crown birds do still have very small wing claws, but they don't really use them for anything for most part. But a lot of them do have kind of weaponized forelimbs, and instead of using claws for this purpose, they often have evolved like various spikes that grow out of different parts of the wing, and oftentimes it's the wrist. And a lot of these birds will use these kind of wrist spikes to either fight off predators or fight amongst themselves. And in some of the plover species, they have these wrist spurs. So yeah, some of them are kind of infamous for swooping at people if you get too close. And if you're particularly unlucky, there's a possibility you might lose an eye from that. Um,
Ooh.
yeah, there's one species called the masked plover from Australia, because of course it's from Australia. Um, is particularly well known for this. There are a few other species that do this too. So yeah, definitely vigorous defenders of their nests, as they need to be for the type of habitat that they live in.
Yeah, the strong hearts for sure.
Mm-hmm.
I still think about that unfortunate incident. It was the last time that killers had nested in our yard
Oh yeah.
was when there was, and maybe I mentioned this story before, but I'll mention it again, where we had a pair that was nesting close to our front door.
Mm-hmm.
So like the way our house works, or our current home works, is that there's a door and there's like a little patio, and then flanking each side is like little tended patches of like decorative rocks and small bushes here and there, and they put their nest right among those rocks, of course, well camouflaged. And like they would come and feed and take care of the nest every now and then. But one day, like we were coming out and we saw that one of the pair seemed to have died
Oh.
somehow. They were like in front of the nest and just kind of flat on the ground, and the other partner was there and kind of like guarding the body,
Mm.
like it would like stand on top of it and flash the wings out and peep at us.
Right.
And we were confused because we had like it was clearly dead, but there was like no sign of like injury
Right.
or apparent injury. At least we don't know if it was a cat or a
Mm.
fox or something.
Right.
And of course, Dad wanted to get the body out as soon as possible to
Right.
keep ants and things from making a little scavenger pile in the front door.
Right.
Nobody wants to come to a house with that. So while the other partner was away, like he disposed of the body, and
Right.
then
Right.
I don't think the nest lasted that long.
Wow.
In fact, I don't even think. Yeah, I don't think they had laid eggs yet,
Ah.
if I
Okay.
remember correctly. So it was just an empty nest.
Wow.
But after that, the partner disappeared, and there were no more plovers that came to our yard.
Oh.
Like we would hear them, but they just did not want to
Right.
in our backyard. It was.
Right. Right.
I to this day I still don't know why. It's strange.
Yeah.
Um,
Yeah.
Yeah, that's a sad story.
Indeed. Wow. Wow. But yeah, that's really unfortunate indeed. But I'm sure they gave you a lot of joy while they were still around.
Oh, of course. I mean, it's why they're my favorite bird. You got used
Exactly.
to them and seeing their little babies running around, and 'cause, I mean, they're very distinct. Like you hear that peeping,
Yeah.
you see those double black bands on the neck, and you
Right.
know, oh, that's a killdeer. It's
Exactly.
might as well be looking at an ostrich. It's so distinct.
Indeed. Yeah. 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 Yeah, they're nice like that. A lot of different shorebirds can be very difficult to tell apart, and some of the plovers can be too. But yeah, killdeer they let you know that they are killdeer. So it's a they're a nice species to see.
Yeah, absolutely. And of course, the name
Right,
it comes from the sound they make.
that's right. Yeah,
It's like if you stress it, it kind of sounds like kill me, kill me.
yeah.
But no, like they don't like they don't like go after deer or anything like
No,
that.
no, no.
I don't think anybody was thinking, but
Right, but yeah, yeah. Just to clear up. Yep. Yeah, all right. Let's see. What have I got next? So here is showing the phylogeny of the Charadrian shorebirds. Um, so we can see that the Magellanic plovers and sheepbills and dickups, they form a little clade. And then the rest form another clade, with the oystercatchers and ibisbills and stilts being particularly close to each other. So that gives you a sense of their diversity there. Do you have anything else to add before we go on to the next group of shorebirds?
nope, everything looks good to me.
Okay, great. So that's the plover-like group. Next, we'll be meeting the sandpiper-like group, the Scolopaci. Now, there are over 100 living species in this group as well. They are known from the Eocene to Holocene, although again the early fossils are not particularly great in terms of completeness, so we can't say too much about them. Um, they have a number of different skeletal features that have been recognized. So one of these is that in the upper arm bone of birds, there is a little notch close to the base of the bone called the capital incisure. And in the Scolopaci, there is a little ridge that kind of closes off this little notch. Um, and so pictured on the left here are the upper arm bones of several fossil Scolopacians. It might be clearest in the one on the leftmost side, so letter J, where it's labeled kind of RIC. That is the ridge that closes off the notch in the arm bone there. So that's a feature that is found in Scolopacians. Some other bird groups have them too, but it's definitely shared among this group. Something else that distinguishes them, at least from other shorebirds or most other shorebirds, is that they're in their coracoid. So there's that shoulder bone again. A lot of birds, although not all birds, a lot of birds have a hole that kind of runs through the coracoid bone called the supracoracoid nerve foramen. And as the name suggests, this is a hole that a nerve actually passes through. Now, in some birds, it goes right through the bone, so there's a hole there. In others, it kind of passes next to the bone, so there's no hole there. And in the Scolopacians, the hole is lost, so there is no hole in the coracoid there. And you can see this in the figure on the right there. So the right letter G is a Scolopacian coracoid, and on the left you can see labeled FNS is a little hole in the coracoid where there would normally be a supracoracoid nerve foramen. And most other shorebirds do have this little hole, but the Scolopacians do not. But this hole has been independently lost in a number of other crown bird groups too, but it does distinguish them from the other charadriiforms. So let's look at some of the different groups within this one. Now, first up, we have a weird group. This is the plains wanderer, which is only known from one living species from Australia. Now, we do have some fossils of stem members of this lineage. So there's one known from New Zealand, for example. But otherwise, there's only just this one living species from Australia, and it is critically endangered, partly because of habitat loss and partly because it gets preyed on by invasive predators, especially foxes. And the habitats that they like are sparse native grassland. So, not just any kind of, grassland you can plant as a lawn or something. In fact, lawns are some of the worst kind of habitats for, biodiversity in general. Um, but the native grasslands of Australia, where there are plenty of native plants, um, and they are omnivorous, so they'll actually eat both invertebrates and seeds, and they'll feed on the seeds of some types of these native plants, which they depend on. So yeah, they are very kind of selective habitat preferences, and that's why they are critically endangered. Now, unfortunately they're also very difficult to observe. I've heard that it is easiest to find them when you're out in the sparse grasslands where they live at night, so you might be able to find them kind of roosting. They're mostly active during dawn and dusk, so they're often considered crepuscular, which is a technical term for that kind of behavior. So they'll forage out during dusk and dawn and kind of rest at night. Very, very difficult. Yeah, you definitely need people who know the area and know the birds well to be able to find them. They don't like to fly very much, though they'll prefer to run or hide from predators. Um, Something interesting about them, and we'll actually see this in a few other shorebird groups, is that the males perform most of the parental care duties. So, incubating the eggs and taking care of the chicks, that's mostly the male's job. And it seems that they kind of adapted to this grassland dwelling lifestyle relatively recently, because we have a couple of fossils of stem members of this lineage, and they were found in habitats, or found in rocks that formed in habitats that were probably not this kind of a sparse grassland environment. In some cases, or at least in one case, it was probably more of a forested kind of environment. In another one, the one from New Zealand, there basically its overall anatomy seems to suggest that it was a more of a wading bird, like a typical kind of shorebird would be. So they probably adapted to this grassland dwelling behavior, relatively recently, and turned into this very unusual species. Now, the group that they're most closely related to is on the next slide. These are the seed snipes of South America. Um, so probably this group probably originated in the southern hemisphere or something like that, and then spread to Australia and then to South America, kind of in kind of these different lineages. Seed snipes are known from 4 living species, and they live in dry, open habitats of the Patagonia and the Andes. So these are shorebirds that don't live on the shore, and neither was the plains wanderer. So yeah, one of these very inland-dwelling charadriiforms. And very unusually for shorebirds, the seed snipes are herbivorous. Now, they do eat seeds sometimes, but that's not really their main diet. They mostly feed on leaves and buds and green vegetation like that. Very unusual for shorebirds. Now, unlike the plains wanderer, seed snipes are quite good flyers. Shorebirds in general tend to be pretty good flyers. They're pretty strong flyers. They're capable of like very long endurance flights. They can now their flight style is mostly flapping flights, so they'll flap their wings repeatedly, and they can go quite long distances doing this, as we shall see. But yeah, seed snipes they've mostly kept kind of a shorebird like flight style, so they have these nice long wings that they can fly very well on, even though they are not, they're primarily terrestrial birds. Okay, let's see. Before we go on to the next couple groups, do you have anything to say about these odd shorebirds?
Well, if I remember correctly, the plains wanderer in
Mm-hmm.
particular used to be grouped with the gruiforms
That's
at
right.
one point before it was found to belong to this group.
That's right.
Uh, which I guess I can kind of understand, like given how unique it kind of looks and lives compared to some of the other shorebirds.
Mm-hmm.
Um, yeah, it's interesting to me. Like the seed snipes, I'm looking at the photo here. Very pigeon-like.
Yeah, right, right.
Not usually what you think of when you think of a shorebird.
No, not at all. Yeah, yeah. And since we have those stem kind of plains wanderers that seem to be wading birds, it seems like even though these two groups are closely related, they kind of evolved to be like non-shore dwelling kind of independently, which is really odd. And yeah, you're absolutely right about the plains wanderer being one of those former gruiforms. So during the gruiform episode, I'm sure we mentioned that a lot of various kind of terrestrial bird groups were formerly grouped into the gruiforms, and the plains wanderer was one of them. But now we know that is actually a very weird kind of shorebird. So is one of those ex gruiforms that got kicked out.
Right. Um, I imagine those kind of play into that idea that the two groups probably have something to do with each other, which
Right. Yeah. Yeah.
I'm
Probably.
sure they'll explain more of that later on.
Mhm. Yeah. Well, we'll be seeing at least one other group that got kind of got a similar treatment. But for now, the next group are the painted snipes. Um, so these are distinct from the true snipes, which belong to the sandpipers. We'll meet the sandpipers later. Um, but the painted snipes do look a lot like the true snipes, except they tend to be more brightly colored. Now, specifically, it is the females of the painted snipes that tend to be more brightly colored. So the one pictured here is a female, and you can see that there's this nice kind of reddish coloration. Um, Whereas the males tend to be more cryptically colored. Now, in the old world species specifically is where you see the sexual dimorphism, and in low species, again, it is the males that tend to do most of the parental care duties. So that is pretty interesting. Mostly painted snipes are found in tropical wetlands. So there's one from South America and two from the Old World. So one is found in tropical Asia and Africa. The other one is found in Australasia. Even though they have relatively bright colors, they can be pretty hard to spot because they might hide in vegetation and things like that. But if they're alarmed, what they'll do is actually spread their wings out very well to throw their wings out to the side, and they expose these kind of bold patterns on the wings. And doing this, they will try to intimidate their enemies this way. Um, Now, if you know birds well, that might remind you of a South American bird called the sunbittern, and we haven't covered sunbittern yet on this show, but we will. And it is indeed a very similar kind of behavior. So yeah, the painted snipes are closely related to the next group, which are the jacanas, and the jacanas are another very distinctive group of the shorebirds. They are also found mostly in tropical wetlands. Um, yeah, so just around the world, across the in a band across the equator or close to it. Um, and what's especially distinctive about jacanas is that their toes and the claws on their toes are extremely long, and you can see this very well in the photo here. What they can do with these toes is that they are able to actually walk on top of floating vegetation, and that's actually where they spend a lot of their time. They just walk across the floating plants, and they'll pick off little insects that they come across on the plants, or maybe seeds. They're little bits of edible material. And in this group, it is also the males that tend to perform most of the parental care duties. And since they live on floating vegetation, they have a pretty interesting kind of behavior. Um, so they'll actually build nests like on top of these floating vegetation mats, and what they'll do is the males, they actually have specially adapted wings to kind of cover the eggs while they're on top of this vegetation. So they'll kind of sit down and then use their wings to kind of scoop up the eggs against their own body while they're incubating them, to keep them clear of the water and all that. So they'll kind of hold the eggs close to their body using their wings, and this is actually reflected in their skeleton. Jacanas have very odd shaped wing bones because as adaptation to increase the surface area for doing this. And not only will they do this with their eggs, because after their young hatch, their young are, pretty self-sufficient, like most of the other shorebirds. But if danger threatens, the father jacana will come over and cover the babies with his wings, and then not only that, but he'll hold the babies against his body using his wings, and then pick them up and run off to somewhere safe. So you can actually find plenty of photos of this online. Just Google like jacana with babies or something, and you'll just see like an adult jacana with a lot of little feet. Well, they're actually not that little. They're proportionately very big feet just poking out underneath its wings, and that's because it's holding its babies using its wings. Yeah,
I love that so much.
yeah.
These are really fun birds.
They are. They are. Yeah, yeah. They are. They're another group that I got to see in Australia. So specifically, this species pictured here, actually the comb-crested jacana. Yeah, definitely one of my favorite sightings on that trip, and there were a lot of good sightings on that trip. So, yeah,
Oh, cheers. Yeah, I've never seen one in the wild.
yeah. I imagine it would be. They there is one in North America, but usually more to the southern region, so the northern jacana as it's called. But yeah, otherwise, yeah, you would have to be in the tropics or pretty close to be able to see them easily.
Right.
But yeah, so jacanas, in terms of their fossil record, there's actually a little bit of interesting story to tell there, because on the next slide, we have giant jacanas known from the fossil record.
Oh,
Yeah, so this is one of the examples. This is the biggest species known, pictured in the labeled A to C on this figure. So this is a Nufaranasa mobocoensis from the Miocene of Kenya, and this is the tarsometatarsus, so basically the bone or the long bones of the foot fused together, and it is being compared from D to I are bones of other jacanas from the same locality, but are more normal size for jacanas. And then you have this massive giant living alongside them. Yeah.
what would that be comparable to in size?
So I would guess now it's not very complete. It's pretty much just this one foot bone here, but I would guesstimate maybe the size of a small chicken or so.
Wow, okay.
Yeah, yeah. So pretty big, pretty big. Um, and it makes you wonder, like how big were the lily pads back in the
Oh,
Miocene of Kenya?
oh. That is if it was using a lily pad.
That's right. That's right. Yeah. If it had similar behavior to modern jacanas, like either they were really huge lily pads back then, or like the vegetation was super dense and it could walk on top of them. Um, and it's the biggest one, but it's not the only giant jacana that is known from the fossil record. So from the Oligocene of Egypt, there are a couple of other giant jacana species. So one of the other Nufaranasa species is known from then. Um, in fact, Nufaranasa means water lily queen, which is a good name for a giant jacana.
Aw.
Yeah, and there's another one called Janipes, which is also from the Oligocene of Egypt. So yeah, pretty cool.
That's awesome.
Yeah, yeah. Well, it would be nice to see more paleo art of these guys. That would be great.
I was gonna say, yeah, well, more paleo art on fossil birds in general. That would be awesome.
For sure, for sure. All right, and lastly, we get to the true sandpipers. Um, yeah, the sandpipers actually have, for by shorebird standards, a pretty decent fossil record. So um, we don't have anything definite from the Paleogene, but from the Miocene onwards, we do see a number of diversity of fossil species, especially in Europe. Um, Now, in modern day, they're certainly very diverse. There are over 90 living species, and they can be found worldwide except for Antarctica, although I think the occasional vagrant makes it to Antarctica. Um, and they mostly breed in open grassy habitats, and they'll spend the winter in coastal regions, but their habitat preferences are very diverse, so there are some that deviate from this kind of pattern. So you have species like the woodcocks, which live in forests mostly and feed on earthworms. Woodcocks have been the subject of some interesting internet memes, as I'm sure you've seen. Like there's a famous GIF of like woodcock kind of bobbing up and down as it walks, which is an interesting behavior that they have. Um,
Oh yeah, I love the music remixes with those.
yeah, right.
You got the funky Spanish music in the background as this thing is bobbing. I love it.
Right, right. Yeah, yeah, very interesting. I think a common suggestion for why they do that is that it helps them kind of drum up the worms from the ground. So worms are very sensitive to vibrations, in the ground because I think the current leading hypothesis is that it they basically see it as approaching danger. So, moles and shrews tunneling through the ground can create these vibrations. And so, if worms detect this, they'll quickly come up to the surface where it's hopefully safe from moles. But, sometimes it's not so safe from woodcocks or people trying to find bait for a fish. So, uh,
Oh,
that's a theory behind that.
that's interesting. 'Cause I've heard the one about rain too.
Right, yeah, yeah, that's another idea too. Right, so yeah, they have woodcocks definitely have very interesting behaviors in that regard. Um, there's also a group of sandpipers called the phalaropes, which are very unusual because well, the way they feed is that they actually swim on the water's surface, and it's actually kind of funny because what they do is they'll actually spin around and around in little circles, and then and in doing so they kind of create this little whirlpool that drives little floating plankton to the surface, and then they'll quickly pick off the little tiny arthropods and other small animals in that mix.
Wow, that's
Yeah,
cool.
yeah, yeah, yeah. Really interesting. And furthermore, the phalaropes they actually spend their non-breeding period out on the open ocean. So yeah, they're these they're pretty small birds, and they just live out in the ocean like that. It's crazy. Um, very very interesting group. But most of the sandpipers kind of live up to their name, I guess. They kind of spend their time on shorelines, um, looking for food, and they come in all shapes and sizes. Like this long-billed curlew is a very extreme example of one with a very long curved bill. But there are other sandpipers, with slightly shorter bills, and then kind of smaller ones with shorter bills still. And then in doing so, they have this kind of niche partitioning where they feed at different depths in the substrate below them, and specialize in hunting for different types of prey. And so many different species of sandpipers are able to live alongside each other without competing too much. Um, their bill, in addition, is very, very sensitive. So actually, I talked about this in our last episode, our news episode, doing the roundup of 2020. I talked about how the stem paleonate group, so closely related to ostriches and their kin, the fossil lithornithids, seem to have this very sensitive bill tip, which they might have used to detect prey items in the ground. And sandpipers are another group of birds that have this kind of specialization. Their bill tip is extremely sensitive, so they can poke it in the ground, and even if they're not directly touching their prey item, they can detect if there's something digging down there or moving, and then they can take the steps required to pull it out and eat it. Sandpipers are also great travelers in many cases. Some of them make the longest non-stop migrations of any bird, and that record is currently held by a bar-tailed godwit. So this is a relatively large sandpiper with a very long, straight bill, and basically it is not the longest migration in terms of the total distance that traveled across the course of the entire migration. We will meet that champion world record holder later. But it is the longest migration made without making any kind of stop for food, because the sandpipers, they feed on the shore, but if they're crossing the open ocean, unless you're a phalarope, you can't just stop in the middle of the ocean and feed there. So once they get going, they go all the way to their destination without stopping.
Wow.
And so this bar-tailed godwit, this one, well, some populations of this species does in general, but this specific one that was recorded, it was migrating from New Zealand to Alaska, and in doing so, it covered over 12,000 kilometers on that one-way trip.
So was that via the Pacific or over the continents?
It was via the Pacific. Yep.
Wow,
Yeah.
that's incredible.
Yeah. Really, really, really incredible journey there. So yeah, so what a lot of sandpipers will do is very important to them is that before their migration they have to fatten up on food as much as they can. Uh, and in fact, I think during this period, some of their internal organs will actually shrink just so they can accommodate more fat or something like that. Um,
Wow.
yeah, yeah, yeah. And because of this, there are certain habitats in the world that are particularly important for shorebirds, especially for sandpipers, because that's where they stock up and fuel for these flights. Um, so one that's gotten quite a bit of attention is on the Atlantic coast of North America. Red knots stop by there and fuel up, and that's when they're feeding
Mhm.
on horseshoe crab eggs, which is very important to them. And now horseshoe crabs, because they are often harvested for use in medical research, because horseshoe crab blood has all kinds of interesting properties. But this is not the series to go into that. But because of this harvesting of horseshoe crabs, there have been concerns that there might not be enough horseshoe crabs to sustain shorebird populations, and so people are really keeping an eye on that to make sure that hopefully it doesn't get too bad. But yeah, sandpipers are a very diverse group. All kinds of interesting strategies for getting food out of substrates, and yeah, a lot of time they are great travelers. So very very interesting group for sure. And they are also a big headache to identify in the field because there are all these different kind of subtle color patterns that distinguish them. And the differences in leg length and beak length, and that can be quite difficult if you're not used to them. So they're a very big challenge for beginning birders and even not so beginning birders too. Anyways, do you have anything else to add about them?
You had mentioned that the true snipes belong to this group,
That's
right?
right. Yes.
I feel like I should mention this. Like, there was this weird pop culture thing. I don't know
Yes.
how common it is now, where like if you're a parent and you want to like get a kid
Right.
to, you'd say, okay, you need to find me a snipe,
Yes.
and I think the idea is that the snipe is like a made up bird. It doesn't exist, so the kid
Right.
is like left like finding it for the longest time, and he won't find it because it's not there. But of course, as we've explained, snipes are real
That's
birds.
right.
So I don't
Yes.
know like what got lost in translation there when this whole thing was being made.
Right, right. Yeah, I mean, now, yeah, I believe the saying it was probably inspired by the fact that snipes are, in fact, very difficult birds to hunt. They are extremely wary, but yeah, I think over time he got kind of transformed into an imaginary species that does not actually exist. Now there, but it's true. There are real birds called snipes, and they are a kind of sandpiper. Apparently they are quite difficult to hunt, although I wouldn't know. Um, and that's apparently where the saying comes from. Yeah, I remember it particularly from the movie Up, actually. Yeah,
Yeah, right.
yeah, yeah,
I found the snipe.
right,
What?
right.
That's
Yeah, definitely one of my favorite movies. But yes, Kevin is not a snipe.
Oh, of course, yeah. I think we even mentioned in the Galliforms
Oh,
episode
we
that
might have, yeah.
she's based on a Himalayan monal with
Right, that's right. Yes, yes.
pheasants. Yeah, but yeah, that makes sense. Okay, notoriously hard bird to find somehow gets transformed into mythical bird.
Right, right. Well, which is a pretty good legacy if you're for a shorebird.
Absolutely.
Yeah, yeah. So let's see. On the next slide, I show the relationships between the different members of Scolopaci. So we can see seed snipes and plains wanderers form a little clade, and painted snipes and jacanas they form a little clade. And the sandpipers are kind of the outgroup to all of them. So yeah, I guess even though they're called or at least I kind of simplified them as the sandpiper-like shorebirds, you can see that the diversity of lifestyles here is quite extreme. So you have kind of very um, inland-dwelling species that live in very dry environments. You also have the ones that specialize in living on floating vegetation, and then ones that live on shorelines. So yeah, quite a diversity there. And if you also remember the phalaropes, you have the open ocean ones too. So definitely quite a diverse bunch.
It's a good group.
It is, yeah. Now, the next group, the Lari, is also an extremely diverse group. Now, this group can be thought of as the gull-related shorebirds. There are over 160 living species, so there are more of them than there are of the Scolopacians or the Charadriians. And some of them, or rather, some of the interesting osteological features that they have are the ones that are pictured here. So they have these ossified tendons along their back vertebrae. We've spoken of these before. So when the tendons are hardened into bone, basically. As far as I know, I don't think we really know why members of Lari have this. Usually, ossified tendons show up when for if the structure needs to be particularly stiff, or if there needs to be some kind of energy saving there to keep the bone kind of springy, kind of. So there's a bit of energy storage in there. Yeah, I'm not sure particularly what functional significance it has in members of Lari, but most of them share this feature. Something else about the coracoid, again, there's that shoulder bone again, is that where the coracoid connects to the breastbone, to the sternum, so the coracoid, it connects at one end to the shoulder blade, to the scapula. It also connects to partly to the upper arm bone, so it forms part of the shoulder socket, and the three bones kind of meet in that region. And then at the other end, it connects to the breastbone, the sternum. And if you pick up a shorebird coracoid and look at the joint surface where it meets the sternum in a member of Lari, the surface is very curved, which is in the red box here, whereas in other birds or other shorebirds, the surface is not so curved. So that's one of the features that they share. But the Lari are a very, very diverse group, and as we shall see immediately on the next slide, the button quails are a group of Larians that do not have either of the features I just mentioned. So, yeah, in fact, it took us a very long time to figure out that button quails even were shorebirds, and this was one of the groups that people had sometimes considered to be gruiforms in the past. But in general, where the button quails fit has been kind of a major puzzle in kind of bird systematics for a very long time. Yeah, like people have placed them kind of all over the map in terms of bird phylogeny, but now we're pretty sure that they are shorebirds. And what an unusual group of shorebirds they are, because as their name suggests, they are very quail-like in terms of their appearance and their ecology. They're not necessarily tied to water. They can be found in quite arid habitats. And yeah, they'll spend most of their time kind of hidden in vegetation. They're usually reluctant to fly. Usually only if they're very pressed very hard will they suddenly burst into flight, which is a very galliform thing to do. And yeah, it can be quite difficult to tell them apart from true quails in the field. In fact, one of the easiest ways to tell them apart is by counting their toes, actually. So and that's if you're actually close enough or actually have one held in your hand to be able to do that. Because these guys are shorebirds, their hallux is highly reduced, and in the case of the button quails, the hallux is lost completely, so they only have 3 toes per foot, whereas galliforms have a typical kind of bird foot where there are 4 toes per foot. And we mentioned in the kind of gallo-and-serin episode that a lot of galliforms will actually still fly up into the trees to sleep for the night, and so that's where the kind of perching toe comes in handy. But yeah, button quails do not have this feature, so that's kind of one of the main or most obvious ways to tell that they are not galliforms. Like in some of the Scolopacians, in button quails, the males actually tend to perform most of the parental care duties. And something else interesting about kind of their growth and reproduction is that they grow super fast. They are some of the fastest growers among all crowned birds, other than the songbirds or passeriforms at least. And crowned birds already have some of the fastest growth rates of any vertebrate. So that's saying something. Button quails, apparently they can grow to sexual maturity in 3 months or thereabouts, which is very fast. Now, let's see. Button quails are found mostly in the Old World, so we don't have them in the Americas. They are found in kind of warm regions, not necessarily tropical, but warm regions of Eurasia, Africa, and Australia. And because of their kind of somewhat secretive habits, I believe they are relatively difficult to observe. Yeah, you'd have to be somewhat lucky to see one, I think.
Hmm.
Now, we actually do have a pretty good button quail fossil record, at least by shorebird standards. We have a possible fossil from the Eocene, although the dating of those rock layers is a bit controversial, so it's actually not entirely clear they're from the Eocene. But definitely from the Oligocene onwards, we have a number of fossil button quails, and I pictured some of the more completely known ones on the next slide. So we have Cerastenia from the Oligocene of France. And you can see that this is a really nice fossil on the left here. Now, the bones are not particularly well preserved. Like, they're pretty crushed, but you can actually see that this fossil actually preserves some of the feathers on it. So, yeah, pretty nice skeleton there. Um, yeah, and another example of a fossil button quail is Turnipax from the Oligocene of Germany. It's actually known from a couple species, but this is a more completely known one. And you can see that there's almost a complete skeleton here. The skull is missing, but not much else is. And yeah, what's interesting about Turnipax, now Cerastenia, because the bones are so flat and it's not easy to see the details there, but in Turnipax, it's some of the bones are quite clearly, like in terms of their anatomy and shape, quite clearly intermediate between what you would see in a typical shorebird and what you would see in a modern button quail. So kind of Turnipax actually provides this kind of independent evidence that button quails are members of the shorebird group, which was originally found based on genetic data. Yeah, Turnipax showed basically how they got to be these kind of weird shorebirds from a more typical shorebird-like ancestor. So that's pretty cool.
Yeah, that's great. I'm gonna say compared to the other fossils you were showing so far, like this is a step up.
This is a pretty damn good fossil record. Yeah, compared to the other shorebird fossils, for sure.
Now, what's interesting about I guess that like if you're just in taxonomy, like
Mhm.
this is interesting to know. Because I understand you have these under Larry,
Yeah, mhm.
or Lard, I guess.
Yeah. Well, either way.
I know that since you mentioned that the button quails are so like unique in terms of their anatomy
Mhm.
compared to everybody else in this group, I have seen some like bird taxonomists actually give them their own like major lineage, I guess you could say. But like I know considering the like we're trying to get away from like Linnaean taxonomy, like the whole idea of like suborders and superfamilies and stuff doesn't really it's not really used that much anymore.
Mm.
So like it doesn't necessarily matter as
Yeah,
long as we
right.
know where what the like the general phylogeny is
That's
like.
right. Yeah. So either way, yeah, I definitely seen that system used as well. I like yeah, like for simplification's sake, and yeah, like you said, it doesn't really matter. But for simplification's sake, I like to think of the charadriiforms as like these three major groups. But yeah, in any
Yeah.
case, the button quails are most closely related to the gull related group, closer than to the plover like or sandpiper like birds at least. That's what the genetic data seem to be consistently um, saying. So, yep, yeah, they are certainly very
Right.
different from other members of the group in their current form. Now, let's see who's next. On the next slide, we have yet another group with only one living species. These are the crab plovers, but of course, since they're members of Larry, they are not plovers at all. And this species is found in coasts or on coasts along the Indian Ocean. So they can be found in Asia, including the Middle East and Eastern Africa. Now, they feed mostly on crabs, which is a major shocker, I know. Um, which you can see that very stout kind of bill is very useful for. So smaller crabs will just grab and kind of swallow whole, but bigger crabs will kind of break the legs off first and then before eating them. So yep, they have a pretty interesting reproductive behavior. Yeah, the reproductive behavior in charadriiforms in general is very interesting, and I don't have time to go into it in this episode, but they're very well studied because they exhibit all these different kind of breeding systems. Some in some cases the male taking care of the young, in some cases both parents taking care of the young, and kind of different degrees of development in the young. Like some are more precocial than others, and all that. So there have definitely been a lot of studies done on kind of the evolution of breeding systems in shorebirds. And in the case of the crab plovers, it's both parents taking care of a single young, and unusually for a shorebird, this young is altricial, so it's not hatched out ready to go. Instead, it has to stay in the nest for a little bit. And in the case of crab plovers, the nest is actually a burrow, so they'll actually dig a burrow in the in the sand, and then lay their egg inside and rear their young inside the burrow. So that's a very unusual behavior for a shorebird. The crab plovers are closely related to the next group, which are the glariolids. Now, this group actually is known from a number of fossil representatives from the Oligocene onwards. So, yeah, we actually do have a number of fossil species that have been assigned to this group. There are 17 living species, and they are found in Africa, Eurasia, and Australia, although there are fossils known from North America. And they include these two different, well, as we shall see, they might not be different clades, but different morphotypes, the pratincles and the coursers. So the pratincles, when the pratincles aren't on the ground, you can kind of see their shorebird resemblance because they'll actually feed in a somewhat plover-like manner where they'll take these short little runs and grab prey off the ground. But one of their primary feeding methods is actually not doing that, but feeding while flying through the air. They are aerial foragers, so they're a bit like a shorebird version of a swallow or a swift. So they'll actually fly through the air, going after insects and grabbing them on the wing. So that is very, very odd behavior. And like some of the other shorebirds, they often nest in colonies. Whereas the coursers are quite different. The coursers are very long-legged, so whereas the pratincles are relatively short-legged. They often live in quite arid habitats, and they're very fast runners with their little long legs. Sorry, that's an oxymoron. With their long legs, and they're very fast runners. They'll run around, grabbing insects to eat and things like that from the ground. And the thing about the coursers is that it might not actually form a clade. Some of the coursers seem to be more closely related to the pratincles and the other coursers are. So yeah, these terms seem to be more ecomorphological terms instead of phylogenetic ones. Now, I said that we actually have quite a few fossils from this group, and most of the ones I've been found so far seem to have more pratincle-like proportions, interestingly enough. So it seems possible that the courser-like lifestyle kind of evolved different times from a pratincle-like lifestyle. That's a possibility. Yeah, but we'll definitely need many more fossils to fill in the gaps, but that is quite interesting for sure. So another group that kind of deviates in some ways from what you would expect of a shorebird, like morphology or an ecology.
That's an interesting case. So if some of the earlier fossils were pratincle-like in their general proportions, and some of the coursers are more closely related to pratincles than the other coursers, then would it be accurate to say that you kind of get a pratincle-like bird into a courser-like bird and then back into a pratincle-like bird, or would it probably be more like the coursers took their own forms independently?
Yeah, that's a good question. I guess we don't really have a complete enough record to say for sure, but it would be cool to find out.
Gotcha. Okay.
Yeah. But definitely an interesting group. I have not been able to see any of these in real life yet, but I would really like to.
Yeah, me too. The pratincle is really cool. Look at the photo here. I don't know if that's just an artifact of it in flight, but for being an aerial forager, yeah, they have that bullet shape.
Yep.
They can go through the air. It looks really efficient.
Yeah, that's right. Yeah, I love that kind of bullet-like shape. I'm pretty sure that is indeed an adaptation to kind of aerial foraging lifestyle. So yeah, very, very cool. Swallow-like shorebirds. Yeah. In fact, when I talk about the Larry, I guess how many occasions I've had to do that, right? But when I talk about them, I kind of describe them as the ones who copy all the other birds' homework because they because they have kind of done a bunch of different things that so many other distantly related groups have also done, but all within this one clade. So you have like the galliform like button quails and the swallow like pratincoes, and we'll see in the next few groups coming up with similarities with other non-shorebird groups too. So yeah, they're a very interesting group for sure.
Absolutely.
So yeah, like the next group coming up, the skuas. So
Hmm.
these are basically a shorebird version of a raptor, basically. The skuas, they don't have a very good fossil record, so we only know them from the Pleistocene onwards. But there are 7 living species, and they breed in polar regions mostly. So if you see them in wildlife documentaries, you'll mostly see them hanging around in the Arctic and the Antarctic. But when they're not breeding, they'll actually hang out over the open oceans, like all over the world. They're also great travelers. They'll fly all over the place and just go back to the poles when it's time to breed. And so, yeah, I said they were the shorebird version of raptors, and that's because they have this strong hooked bill, which you can kind of see in the photo here. And they also have hooked claws on their feet too, for kind of holding their food down. And in most cases, their food is meat. Um, so they will hunt smaller vertebrates, and by that, they'll catch fish, sure, but they'll also hunt small mammals for in the Arctic species too, at least, and they also hunt for smaller birds too, including the chicks of other seabirds. Um, and they're kind of infamous for their feeding behaviors because not only do they go after baby seabirds, but they also like to steal food from other seabirds. So when other seabirds have caught a fish or other kinds of seafood, they'll often chase them down and harass them until they drop the food, and then the skuas come in and grab the food from them. So because of this, I guess I feel like they're often cast in a pretty negative light, I guess, in pop culture. Like even in wildlife documentaries, like you always see them kind of hunting for baby penguins or like chasing other seabirds and
Yeah.
yeah, being very aggressive and all of that. Which is I don't know, it's a bit of a shame, I think, because they are very interesting birds in their own right, and I would love to see a wildlife documentary that actually focused on skuas as the protagonists of a segment and not as kind of the de facto antagonists, because they actually have to work really hard to take care of their own young, and again they're breeding in polar regions, so when you're seeing them, you hunting for baby penguins, that's when the skuas are trying to get enough food to feed their own babies as well, and it is actually very difficult for skuas to successfully rear young, at least for the Antarctic species. Um, skuas can live for a long time. They can live for like 30 years or more. But in that time, I've heard a figure from a skua researcher saying that like they probably only successfully rear like 5 young or so within their lifetimes. Um, and that's because the weather in Antarctica is, of course, very harsh. So on some years, there are just bad years, and the babies don't make it, or they can't find enough food to sustain them. And the thing about going after penguin chicks is that it is actually not really a piece of cake for the skuas, because skuas look big and mean, but if you think about it, an adult penguin actually outweighs skuas by a lot. Like even a small species of penguin, like an Adelie penguin, um, like a skua weighs, it's like the size of a chicken. It's a kilogram or so. Adelie is like what, 7 kilograms, so many times bigger than a skua.
Wow.
And of course, penguins, because they don't have to fly, have very dense bones. Um, Whereas a skua has a very typically, bird skeleton with very hollow bones. So if an adult penguin actually grabs hold of a skua, it can just pound it flat and, not without even blinking. Like the skuas are actually risking a lot to harass penguins because adult penguins, can easily hold their own against a skua. So, kind of going after penguin chicks is a very risky and kind of high reward kind of behavior for skuas. Yeah, I think it would be cool for a documentary to kind of show that side of them. I personally, don't like to think of animals as good guys versus bad guys or whatever. That kind of
Mm.
very moralistic kind of thinking. But I think it really was an article in on Cornell's All About Birds website. It it was done kind of interviewing a skua researcher about skuas, and it kind of gave me really this kind of fresh new perspective on them. Um, that made me really want to see a focus on them more in documentaries. So, on the off chance that any documentary maker is listening to this, I think that would be a good story.
Wow.
um,
Yeah, I tend to agree with you on that. Absolutely. Yeah, I was thinking the same way as you were describing it. Like growing up and consuming animal media. Yeah, the skuas were the bad guys. That they were sleazy, sneaky birds that would come in and harass the cute, lovable penguins because
right,
the penguins were always the stars, and you always wanted to root for the penguins. Whenever the skuas come around, you be like, no, go away.
right.
But like treating them as actual animals and seeing like the hardships that they go through like you were talking about, it's like, yeah, like they deserve as much love as any other bird, really.
Right, right. Yeah. And something really interesting about them is that they're pretty smart. So for first of all, so being the dutiful parents that they are, they defend their nests very aggressively. And since they're these kind of raptorial birds, they can do that quite well. So kind of researchers up in the Arctic and Antarctic have many experiences of being dive bombed by them. Um, Now, something interesting is that in at least I think the species studied was the brown skua. It has been shown that they apparently are able to recognize individual humans. So they'll actually remember individual humans who have kind of come too close to their nests, and they will target those humans if if there are two different humans, one who has been too close before and one who hasn't. They will target the one who has kind of trespassed on their territory before. Um,
Oh, wow.
and which is really remarkable if you think about it, because they breed down in Antarctica where normally there aren't any humans, right?
Right.
It's like humans are a very recent thing on that continent, but yeah, they are able to recognize that. So yeah,
That's
they seem to be pretty intelligent, and I think if people studied them more, I'm sure we'll find out what more they are capable of. Because in the same paper that described this, the researchers mentioned that this is not the case for some of the other birds that breed in Antarctica. Like some of the terns, for example, are also quite aggressive when they're defending their nests, but they don't preferentially harass like people who have individually kind of trespassed too close to the nest. They just they're kind of indiscriminate, but skuas seem to be able to do that. Um, so that is quite interesting for sure.
Yeah, I didn't know about that at all. That's incredible. Because
Yeah,
like you usually hear about that in like the context of like corvids.
right.
Crows do that sort of stuff.
Of
But
course, yeah, and you kind of expect intelligence from corvids, uh, but yeah, definitely not so much from a shorebird. So that is definitely a very cool kind of discovery. Yeah, I actually, as you can see, I actually quite like skuas a lot. I will link that article I mentioned in the description below because I think it's worth reading. And there are a lot of nice photos of skuas in that article, including a cute baby ones too.
oh,
Because like other shorebirds, they hatch out kind of cute and fluffy, so they don't grow up into like these kind of brute like appearances until much later.
right. Yeah,
Yeah.
that's awesome.
Right, right. Yep. So kind of the raptors of the shorebirds, and kind of like falcons almost. Their wings are very long and pointed and good for chasing down other birds, which are is useful when they need to kind of steal food from them. They don't always do things that are nice by our standards, but it's a way of life for them, and nature is does not conform to our moral standards.
Right.
All right. Now, kind of pretty interestingly, skuas are most closely related to, their closest living relatives are the auks among the shorebirds, which I think a lot of people don't expect. Um, Now, pure, as far as I know, this is pure coincidence, but it was pointed out to me, and it's pretty amazing, is that auks spelled backwards is skua.
Oh my gosh.
Right.
I didn't. Wow. What are the
Yeah.
odds?
Like, wow, yeah. Yeah, that's pretty amazing. Yeah, I'm pretty sure it's a coincidence, but yeah, so first of all, they happen to be each other's closest living relatives. Also, auks are sometimes a target of being what we say kleptoparasitized or robbed by skuas. So that's an interesting relationship they have there. Family reunions must be awkward there, but auks are quite a different group of shorebirds in terms of their way of life. We have a decent fossil record for auks from the Miocene onwards, at least. There are a lot of different fossil auks that are known, especially from both the east and west coast of North America. There are many different fossil auks. Earlier than that, the record is much sparser. There isn't so much, but there is an Eocene fossil that seems to be an auk. So their known time ranges from the Eocene to the Holocene. Currently, auks are only found on the in the northern hemisphere, and as far as we know, I think they've always been restricted to the northern hemisphere, where they breed on Arctic and temperate coasts. During the non-breeding season, they live out on the open ocean, and they're very good at that. They're wing-propelled divers, so they dive and swim underwater by flapping their wings, and in this way they are convergent on penguins. So yeah, there we go. The shorebirds are copying other people's homework again. Yeah. Now, unlike penguins, all living auks can fly. We will meet a few flightless ones later, but all the living species are able to fly. And this creates a bit of a compromise because a wing that is good for moving through the water is not necessarily optimal, and indeed is not optimal for moving through the air. So, because of this, auks actually have to spend a lot of energy to fly, and they have to fly very quickly to stay airborne. So their flight tends to be very fast and very straight. Yeah, they are fast flyers, but it is energetically pretty costly for them. Now, most of them will nest in colonies, and they have a number of different different types of nesting behaviors within this group. So some of them like to nest on cliffs, so these sheer cliffs where land predators can't get to them. That's pretty helpful. Others like to nest in burrows, puffins, for example. So I guess in case you weren't aware or haven't been tipped off by the picture here, puffins are a kind of auk, and puffins like to nest in burrows. And well, something kind of interesting is that puffins actually have these very long, curved claws on their feet, and you might be able to make it out in this picture. In fact, the long, curved claws on the feet for digging burrows, and this is actually one of the similarities they share with skuas. So that's kind of a bit of a family resemblance there, even though they live kind of very different lives. There are even a few species of auks that nest in trees, believe it or not. Yeah, they will actually live in old growth forests, and they'll build a little nest on a very broad tree branches and just lay their eggs on top of it. Yeah, so very varied kind of a behavior, and there are others too. Some of them nest in rock crevices and things like that. But basically, any place that keeps them safe from land predators. And I think you can make a case that some of the auk species are the most marine dinosaurs that we are aware of. I guess technically we don't know how much time that things like Hesperornis spent at sea. So potentially Hesperornis could have been like the most marine dinosaur ever. But in terms of living birds, at least, and certainly marine behavior is much more common in crowned birds than in Mesozoic dinosaurs. Uh, Auks are considered, or at least some species of auks are considered to be the species of birds that spend the most amount of time at sea. In fact, some species uh, leave for the ocean, when they've just hatched. Within 1 to 3 days of hatching, they run to the ocean and just stay there until they're old enough to breed.
Wow.
Yeah. So, yeah, the particular species I'm thinking of is called the ancient murrelet. I think there's a segment on the life of birds about the species. Yeah, when the young hatch, they're not fed at the nest by their parents. Instead, the parents they wait for their chicks out in the ocean, and then within a few days of hatching, the babies climb out of the nest, and usually in the darkness of the night, so they hopefully aren't picked off by predators, although that is still a danger. And they just run all the way to the sea, and they rejoin their parents, who they kind of find by call, I believe. And so they just spend most of their time out in the ocean from then on. Yeah, quite a remarkable group. And a lot of the auks have brightly colored bills or kind of elaborate plumes for display. So puffins, of course, have these really brightly colored bills during the breeding season. And when it's non-breeding season, they'll actually shed kind of the outer kind of covering of their bill for a more dull colored one. And there are some other auks species that have these weird tufts or similar structures of feathers on their head and things like that. So that's all kind of interesting socio-sexual display structures. What's interesting is that sexual dimorphism is not very strong in auks. So both males and females tend to develop these display structures, and this is called a mutual sexual selection, or rather is an expression of mutual sexual selection, where both sexes kind of choose each other and kind of evaluate each other's quality based on these sexual display structures. And this, of course, has inspired a number of papers about the subject, speculating about its presence in Mesozoic reptiles. So people have suggested, including some of these papers were co-authored by our good friend Darren Naish, where he suggests that people have tried to identify sexual dimorphism in Mesozoic dinosaurs, but it's a lot of this evidence is very ambiguous and equivocal. What if they really didn't have a lot of sexual dimorphism, and instead, both males and females were kind of choosing each other using these display structures, so which is certainly a possibility. And so sometimes you hear the idea like, oh, if these structures are for display or sexual display, they must be sexually dimorphic, which is, yeah, completely bogus. Certainly a lot of sexual display structures are sexually dimorphic, but it's definitely not a guarantee. And the auks are definitely one example of this. And it's found in other birds too. It's not that rare. I've seen people say, oh, yeah, but these are exceptions. Like, it really isn't that rare, actually. Some lessons for interpreting the fossil record there. I will go on to the fossil auks next on the next slide. There's a quite wide diversity of fossil auks, but I specifically want to focus on kind of flightless extinct auks, because flightlessness has evolved a few times in auks, and as I mentioned, because of the compromise between kind of underwater flight and aerial flight, it is not a surprise that some auks have kind of ditched the aerial component entirely and just become fully dedicated wing-propelled divers. And one of these extinct auks actually lived very recently, into historical times. And this is the great auk, which is pictured on the left here, a stuffed specimen. So the great auk died out in the 19th century because of overhunting. It was hunted for its feathers and also was hunted as food, I believe. And also its eggs were collected as well. So yeah, eventually that was too much, and they all died out.
Yeah, it's a very sad story.
Yeah.
Feel like there's that account that there's one sailor who went to one of the islands where these birds were breeding, and there were just two, and they had like one egg with them, and the dude just straight up clubbed the two of them and crushed the egg underfoot, and that was sort of I think there were like a couple of like sightings afterwards, but that was basically it for the great auk.
Indeed, yeah, I think that is indeed commonly said about the last sightings of the auk. Like, yeah, there were a few more after that, but now we're pretty confident that they are extinct, unfortunately. Yeah, the great auk was until recently the largest living auk species. So I think it got up to like 5 kilograms or so like big chicken or small turkey size. And it was closely related to a kind of auk called the razorbill, which, if you look at a razorbill, you can easily see the family resemblance. So the beak shape is quite similar, and the overall coloration is also pretty similar.
Mm-hmm.
But of course, the razorbill is able to fly, whereas the great auk was not. Something else interesting about the great auk is that, in fact, the word penguin was originally used to refer to the great auk and not to the birds that we now think of as penguins. So in fact, the scientific name of the great auk is Penguinus, the genus name. So that's because the word penguin was used to refer to the great auk first, and then people came across these very similar looking birds in the southern hemisphere, and they're like, oh look, penguins. So now we call the southern hemisphere birds penguins, but originally it was a name for this species. Um, if you go further into the past, there was actually a whole radiation of flightless extinct auks, and as far as we can tell, they were not closely related to the great auk. Currently, it is thought that they were actually a group of stem auks, so they were equally closely related to all of the living auks and kind of the early offshoot of this lineage. These are called the Mancalian auks. They could get pretty big. Like not all of them were huge. Some of them were like around the same size as the biggest flying auks today, but the biggest ones, including Myomancala howardi, which is pictured here, the skull of which is pictured here, could get bigger than the great auk. I think estimated about 7 kilograms or so. So yeah, it was a pretty big bird. Um,
Wow.
and as you can see, the skull here, this is a basically complete skull. Like maybe the back of the brain case is missing, but you can see like the bill shape and where the eye socket goes. The eye sockets they were kind of O over there. So the bill shape is quite different from that of a great auk. So maybe they were feeding differently. Who knows? We actually don't know that much about how the great auk was feeding. Um, and the Mankaling auks were actually even more specialized for wing-propelled diving than the great auk, and you can see that in the wing here. So this is the wing of one of the species of Mankaling auks. Um, so in these flightless wing-propelled diving birds, the wing is often very stiff. In crowned birds, and in a lot of them, their close extinct relatives too, the wing can actually fold up very tightly because they keep their wings folded close to the body, where the wing feathers won't get in the way or drag around or anything. Um, but if you want to swim very efficiently underwater, it is better to have a rather stiff kind of paddle to swim with and propel yourself through the water. And of course, in the water, kind of flightless wing propelled diving birds tend to have much shorter wing feathers, so kind of dragging the wings around is not so much of an issue. So in penguins, the wing is very stiff and kind of stuck kind of straight out, and you can see this if you watch them for a little bit. They can't really fold the wing up like a typical bird can. Now, in a great auk, the folding ability is reduced compared to a flying auk, but it is still able to fold the wing, and you can see that in the mounted specimen there. The wing is folded, but in the Mancalian auks, the wing is much stiffer, and it's the folding is very much reduced. So the figure shown here is basically the maximum folding that a Mancalian auk could do with its wings, and as you can see, the wing is kind of stuck mostly straight out there.
Hmm.
So the Mancalian auks, they are known from the Miocene onwards. So there's a number of different species known from the Miocene. The last of them are known up to the Pleistocene. So they lived until relatively recently, but then they died out for reasons that we are currently not really sure of. But they do represent a very nice, interesting story in auk evolution. And I should also mention that the Mancalian auks, as far as we know, were restricted to the North Pacific, whereas the great auk lived in the North Atlantic. So these two independent forays into flightlessness in different oceans. Yeah, so the Mancalian auks, their fossils are known from Western North America and also Japan as well.
I'm curious because hearing you talk about the limitations on folding the arm in the mancalings, I wonder how that compares to some of the extinct maniraptors. Because
Yeah,
I know to a certain point the arms are more easily folded against the body, but
that's right.
in living birds, of course, it's what we're typical of seeing. It's like very folded in there.
Yeah, it's very extreme in crown birds. Yeah, that's a good question. So, I would say in most even in Mesozoic Peniraptorans, the wrist at least can fold more than you'd see in the Mancalian over here. Like there's almost no wrist mobility here at all in the Mancalian, as you can see. Whereas in a in a Dromaeosaurid or an Oviraptorosaur, the hand could fold further back than that.
Gotcha.
Yeah, so definitely a very stiffened wing we're looking at here. All right, so I believe there is one more group on the next slide of the Larry, and these are the gulls and terns and their relatives, collectively known as the Larians. As we shall see, they are known from fossils from the Oligocene onwards. Um, I wouldn't say they have a great fossil record, but we do have a decent amount of their fossils compared to some of the other shorebird groups we've been looking at. They are extremely diverse, over 90 living species, and they can be found all over the world, including Antarctica, a very successful group. They're mostly coastal, but some species prefer to live inland, sometimes far from the ocean, and some of them can be found out on the open ocean when they're not breeding. So very diverse range of lifestyles there, and that's one of the reasons why some ornithologists and a lot of birders don't like to use the term seagull, um,
Right.
and that, that's because partly because not all gulls can be found at sea, and even the ones that are are often found coastally can do pretty well in inland habitats sometimes. So sometimes people get nitpicky about that. I I personally don't mind that much. I try not to use the term, but I don't particularly care if someone uses the term seagull. So don't worry, you're safe with me. but but yes, they are indeed quite diverse in their habits and their habitats. They tend to have very long wings, and you've seen this if you've seen a gull fly. They have a very long wings that are very good for soaring and can also be quite acrobatic as well. And they're quite strong flyers, and terns are also very good flyers. And since they tend to be much smaller and daintier, they are even more kind of agile in the air. So a lot of great flyers in this group. They're also very diverse in terms of their feeding strategies. So your typical gull, of course, is a kind of opportunistic kind of forager. So they'll go after just about anything they think is edible, and I'm sure people who frequent places where they live know this very well. You don't keep your eye on your chips; they'll be gone.
Oh,
Yeah.
I have stories.
Yeah. Um, because of this, I think gulls are another group that tend to get a bad rap. Um, which I think we should learn to appreciate them more. They are actually very majestic birds when you take a proper look at them. I mean, just look at the photo of this one, like that nice pure white and gray contrast. Like it's a nice looking bird, and it's actually quite remarkable that some of these birds I think get quite large can survive so well at so close to human habitation. Um, and I think another thing is that even though we see them around us so often, some of them are actually in trouble in their native habitat, um, because of course there's a lot going on with the oceans right now. But part of the reason that a lot of these birds have colonized kind of these human habitated regions is because that they can't find enough food out in the ocean that they would be seeking out normally, and that's why they're here. Um,
Mm.
so yeah, it's not entirely fair to blame them for some of our misfortunes.
You gotta wonder what their health must be like.
Yeah, right,
There's
right,
a lot of these birds that like live near cities and they're eating like
right.
French fries and oh my gosh, that can't be good for them.
No, probably
I would
not. I think there have actually been some studies on that, and I think the results are yeah, that there is some negative impact, I believe. Um, so
wow.
yeah, not great. Yeah, but there are other members of this group that don't quite feed in the same way. They're not so much feeding on trash and things. It's like a lot of the terns, for example, are more plunge divers. So they'll fly out over the ocean or over a body of water, and they'll spot a fish and kind of plunge down the ocean or the water and grab a fish and come back up. Um, so that's a pretty common way for them to feed. And then there's a very unusual group of larids called the skimmers, which have a very weird way of feeding. So in the skimmers, the lower jaw is much longer than the upper jaw, and so what they do is they will fly out over the surface of the water with the jaw trailing through the water surface, and if they hit hopefully a fish, they will with that lower jaw, they will quickly dip their head down and grab the fish, and that's the way they feed.
And now, is that how pterosaurs feed, Albert?
Yeah, so it was a popular idea for a long time that this was how a lot of different pterosaurs fed. But it turns out, after doing more detailed studies and all that, pretty much none of the pterosaurs we know of have adaptations for doing this kind of feeding behavior. So this is no longer thought to be particularly likely. And in fact, there was like a biomechanical study that showed that if a pterosaur tried to do this, they would meet so much resistance in that jaw that the jaw would break or something like that.
Hopefully. Yeah. Oh.
Yeah, so probably not. Probably not, as far as we know, at least. Um, Yeah, in fact, skimmers are like extreme in terms of kind of all the adaptations that they have for this kind of feeding behavior. It's not something that, just any random bird can do just because it can fly over the water or something. Yeah, like, there are a few like terns that also do this, but other than that, yeah, it's not a super common kind of feeding behavior. It's a weird thing that skimmers do. Um, most types of larids they nest in big colonies, and they will try to find places where uh, again land predators can't really get to them. So that usually means like remote beaches or far off islands and things like that. And because of these colony nesting habits, it is very important if there are shorebird colonies, not just larids, but all kinds of shorebirds. If there are shorebird colonies around, it's important to keep kind of people off those beaches so those birds won't be disturbed because they have very specific kind of habitat requirements for the types of nesting grounds that are good for them and allow them to rear their young successfully. Um, Now, because the larids are very good flyers, some of them are champion migrators, and as I mentioned earlier, the animal that makes the longest migration in total distance that we know about is a larid, and this is the Arctic tern, um, which migrates from the Arctic to the Antarctic. So it breeds up near the Arctic, but in non-breeding season it goes down to the Antarctic and spends there for some time before going back. And as you can imagine, migrating from pole to pole is an incredible journey. And not only that, but the Arctic tern does not fly there in a straight line. They actually take a really convoluted kind of journey. So people didn't know this until they actually put like kind of tracking devices on them to figure out exactly what route they were taking. But the Arctic terns they actually go through a very convoluted journey to get between their different non-breeding and breeding grounds. So what they are doing is actually they are following the regions where the winds are most favorable for flying, as well as the best feeding patches. So I mentioned that the godwit, one of the sandpipers earlier, has the longest non-stop migrations that we know about, and that's because the godwit can't stop in the middle of the ocean to feed. But Arctic terns, of course, they can just fly over the ocean and catch fish and whatever. So and they can also land and sit on the ocean for a bit if they need to take a rest. So they're not going non-stop. But in terms of total distance traveled, it's still a very remarkable distance, and the annual round trip that they make can be around 90,000 kilometers.
Wow.
Yeah. Yeah, like I've seen it quoted like something like in its lifetime, an Arctic tern can fly the equivalent of several round trips to the between the Earth and the Moon or something like that.
That's amazing.
Yeah,
Yeah, the Arctic tern was always one of those birds I would read about growing up. That was
right,
like a super bird because it could do this sort of thing.
right, exactly. Definitely a super remarkable creature. I actually have been lucky enough to see an Arctic tern once. So I was at the Slimbridge Wetland Center, which is a kind of wetland preserve around here in southern England, and yeah, it was in April or I believe, so there was one probably passing through on its migration, and yeah, it was just hanging around. I saw it kind of swoop over the water several times and just looking for fish probably. Yeah, really cool creature, and I've seen a number of other tern species before, and they are remarkable to watch in flight because they are one of those birds you look at and you can just get the sense that they are defying gravity. The air is their domain, and they're just kind of flitting through it without a care in the world. It's very cool. Hmm.
Yeah, I think I've seen terns a few times
Yeah,
before, actually. Maybe not Arctic terns
right,
specifically, but
right.
like they are kind of like they have like distinct profile
Right.
where oh, that's a tern.
Yeah, right.
Uh, Gulls certainly.
Oh
Who
yeah.
hasn't seen a gull in their lifetime? Like that's almost a given.
Right.
Like wherever you are. No, I think they're fun birds too.
For sure, yeah.
I am like impressed by like some of their sizes. Like
Yes.
until I went to well, there's a museum in Maine that I always frequent. It's a little old facility, the L.C. Bates Museum, very Victorian-esque. I'm talking like cabinets full of shells and stuffed animals, and I eat that stuff up.
Mm.
And their bird room is really impressive, and they have like all the birds that are found in Maine, so you can get
Wow.
like kind of a an in-person field guide if you like
Right.
to the area. And some of the gulls, I'm just like, wow, these things are huge. They're like dogs
Yeah,
in
right.
terms of like little, like small, maybe like dachshunds or something like that, or
Right, right.
maybe a cocker spaniel. It's impressive.
Right. Yeah, yeah, they can get pretty darn big. Yeah, I know the largest gull in the world is the great black-backed gull, and yeah, that's a really large animal. It is actually an apex predator in some parts of its range. Like, yeah,
Oh wow.
yeah, 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 because pretty much the only things that are likely prey on it are like sea eagles or something like that. Um, so yeah, they can eat. They'll eat other seabirds, or they'll eat like smaller seabirds like puffins, and they'll eat rabbits. Yeah, it's a pretty impressive birds for sure. Yeah.
Yeah, I mean, there is like a regality to them, like you were talking
Mhm.
about. That it's just like they kind of know where they're at in the world, and they just kind of like hold themselves in pride.
Right. Yeah. Yeah.
Like, nobody's gonna mess with me because I'm a gull, and
Right. Right.
like I don't know if this was like by choice or not, but the image you chose where it's got like the 1 foot kind of tucked in, I used to see that all the time, and
Mhm.
it always cracks me up. I love it.
Yeah. Yeah. The one-legged pose in birds. Yeah. That's a very distinctive one.
So I'd always see them. Like one of my favorite things with gulls is like whenever we like be on like long car trips, when we go over a bridge, and it takes a while to go over the bridge, and there's like the little lamps that you keep passing by, and there would be like a lamp, and then a gull on one of the lamps, and then a lamp, and then a gull on one of the lamps, and this would like repeat. So like, there's always a gull every other lamp, just
Oh, that's
keeping an
funny.
eye on things.
That is funny.
Uh,
Amazing. A constant fixture.
right.
Oh, that's cool. Yeah, yeah. So definitely a very distinctive and in many cases very familiar group of birds. Yeah, but definitely I do encourage people to, next time you see one, stop and actually observe it and take a look at it for a bit. They have a bunch of interesting behaviors, and again, it is it's very cool that such large birds can survive in close proximity to us. Now, let's see. On the next slide, I believe I have an example of a fossil larid. So this is Laricola, which is known from several species from the Oligocene to Miocene of Europe. Um, Now, in one particular locality in France, there are a lot of different fossils of this early larid. So we have a pretty good idea of its anatomy. So this is a skull, for example, and that's a very well preserved skull for a bird fossil. Um, as you can see, the bill is not quite as hooked as a typical gull's bill. It's a bit more tern-like, um, and I don't picture the limb bones here, but its hind limbs are a bit longer than you would expect in a modern larid, so that's kind of interesting. So yeah, kind of this. It's about the size of a small gull or so. So this smallish larid that was a little tern-like with long legs. Yeah, it must have been pretty interesting to see in person. And as for its phylogenetic position, we currently think it's probably a stem larid, so it doesn't belong within the modern radiation of larids, but is equally close to all of them. All right, and on the next slide, I show the relationships between the different Lary groups, and so of course I mentioned that the skuas and auks are close relatives, and they in turn form a clade with the Larids, and then the Glariolids, the pratincoles and corvisors, form a clade with the crab plover, and the button quails are kind of the odd one out, as as you might expect. So that's their phylogeny. Do you have anything else to add?
Nope, everything looks good here.
Alrighty. So, on the next slide, I'll briefly mention that I said that the early fossil record of shorebirds is not great, and we don't know much about it. Um, Yeah, it's true. We only have like a few specimens from the Eocene that we're pretty sure are shorebirds, and most of them we can't even tell what kind of shorebird they are. So yeah, it's a big kind of mystery there. So even though shorebirds are so diverse today, um, they seem to have been, maybe they were kind of late bloomers in kind of their evolutionary history. We don't really start seeing like very abundant shorebird fossils until later, like during the Miocene onwards, and even then we still have missing records for a lot of different groups. However, there are at least two Eocene birds that are known from pretty complete skeletons that might be closely related to shorebirds, and this is Scandiavis from the Eocene of Denmark, and Namavis from the Eocene of Wyoming, from the Green River Formation. There's a lot of bird fossils preserved. Um, and these two birds are relatively similar to each other, and they have a few kind of shorebird-like features in parts of their skull and their vertebrae and their hips. But we are not entirely sure what kind of birds they are. There was a recent study, that the one that described in Namavis, which found in some analyses that it was instead more closely related to gruiforms instead. So who knows, right? Um, and if gruiforms and shorebirds have something to do with each other, then maybe that's not a fluke. Like maybe Namavis was like a stem member of that group or something. But that's kind of speculation. Um, it's kind of a shame that in neither of these two taxa, the forelimb elements are preserved. So yeah, we don't have the wing bones or shoulder bones from these birds, and because those bones in shorebirds tend to be pretty distinctive. I talked a lot about the coracoid earlier and all that. So it's unfortunate we don't have them for these two. Otherwise, maybe we might have some more clues about what they might be. But either way, they're very nice fossils, and potentially they might be our best look at what the early shorebirds were like. So they're pretty interesting for sure. So on the next slide, I show just kind of the general relationships between the major shorebird groups, and as well as the possible positions of Scandiavis and Namavis. Um, yeah, so the Larians and the Scolopacians are more closely related to each other than to the Charadriians, plover-like birds, based on molecular data, which has been pretty consistent. Kind of these general relationships, are not really that controversial. With the genetic data keep giving us the same results mostly. Now, if we go within the groups, like within plovers or within the gulls, that's where the controversy starts. Like how many species are there? Which species are like the same species as this other species? Like yeah, that's a mess. That's a complete mess. But yeah, we're not going to go into that much detail for this series, so we can kind of dodge all that. Um, okay, kind of the final thing I wanted to discuss on the next slide is the transitional shorebirds hypothesis. And if you read like moderately old uh, literature about fossil birds or the origins of modern birds, we will likely come across the term transitional shorebird.
Yeah, my correlated history of the Earth poster uses this.
Yeah, definitely it doesn't seem to be that uncommonly seen. Um, Now, the reason this term was coined is because we know of a number of bird fossils from the very end of the Cretaceous that have some resemblances to shorebirds. And so it was supposed that these fossils were basically the birds that gave rise to all the living crown birds, basically. And so they were hypothesized to be ancestral to some. Well, in some cases, like the authors said that maybe these are link shorebirds and gruiforms specifically or something. But there were other authors that suppose that all living birds descended from these kind of transitional shorebirds. Okay. And furthermore, there were a number of molecular clock studies done in the kind of mid 2000s or so, or late 2000s thereabouts, that seemed to suggest that shorebirds, charadriiforms, originated all the way in the Cretaceous, and that they had already diversified quite a bit back then. People had this idea that shorebirds were around in the Cretaceous. But if you want to learn more about the controversies regarding kind of modern bird molecular clocks, you should go back to the first episode of Dinosaurs, the second chapter. I talk about a lot about this subject in that episode. And as I mentioned, it is quite probable that a lot of these early molecular clock estimates are overestimating the age of these crowned birds. So it's a lot of the more recent molecular clock studies put the origin of modern shorebirds actually much later. So, at most, like very end of the Cretaceous, but maybe not even that, maybe afterward. So yeah, so what's up? Well, what's up with this whole, these shorebird-like fossils, and did modern birds evolve from shorebirds or not? Well, I will say that the transitional shorebirds hypothesis, in terms of the idea that shorebirds, charadriiforms, gave rise to all other living groups of birds, is no longer widely accepted, and there are a number of different reasons for this. So first of all, again, we don't have any good, definite, very convincing shorebird fossils that are older than the Eocene. Even the Eocene fossils are really sparse. Um, Also, all these supposed Cretaceous shorebird fossils are very fragmentary, and I pictured one of them here. So this is part of a coracoid. Like that's it. That's all we have of this particular bird. And if you only have like this one little piece of a bird, it can be pretty difficult to tell exactly what it is. Like sure, some birds have very distinctive bones, but we know that a lot of birds have very convergent kind of morphologies in their individual bones, and usually it's better to have a whole skeleton for you to be able to tell what it is. And so all of these supposed Cretaceous shorebird fossils are very fragmentary, so we can't really be sure that they really are shorebirds. And in fact, we do know that there were a number of taxa that are more likely to have been around in the Cretaceous that had these shorebird-like features. So, for example, a lot of the stem birds that are very closely related to crowned birds, things like Ichthyornis, had very shorebird-like kind of skeletons. Like Ichthyornis had teeth, but that's about the main difference it had from a modern bird. In terms of like the rest of its skeleton, it was very kind of modern bird like, and in some of its features, it's actually specifically very shorebird like, or at least very similar to specific kinds of shorebirds. So, maybe these fragmentary fossils are actually like Ichthyornis, like stem birds, and not actually crowned birds at all. And we also have presbyornithids, which are, I mentioned in the Gallowantceran episode, are probably a group of stem waterfowl. They have some shorebird-like features, and in fact, some early hypotheses suggested that, presbyornithids were the link, transitional form between shorebirds and waterfowl, and that these groups were closely related, which we know is wrong now. Waterfowl are definitely not closely related to shorebirds. But nonetheless, that goes to show that presbyornithids had these shorebird-like features, and there might be some presbyornithid fossils from the Cretaceous, and certainly in terms of their phylogenetic position, I think it's more likely that there were Cretaceous presbyornithids than there were Cretaceous shorebirds, so maybe some of these bones are actually presbyornithids. And furthermore, in molecular phylogenetic analyses, we almost never find any kind of support that, the shorebirds are particularly kind of, you know, I don't really like using this word, like a basal group in modern birds. So we don't find them as like the sister group to all the other modern birds, for example, and which you probably might expect if the shorebirds kind of gave rise to all the others. And we definitely don't find the other birds nested within the shorebird group. So yeah, so we don't really think that charadriiforms gave rise to the other modern birds anymore. But I would say that it is not that crazy that a shorebird-like ancestral ecology was, you know, a thing for crowned birds. I mentioned presbyornithids earlier, and they have shorebird-like features. I mentioned that kind of the closest stem bird relatives to crowned birds have shorebird-like features. And if you recall Asteriornis was probably a stem Gallowantceran, or at least a very early branch of either the Galliform and Seriform lineages. We have some parts of its hind limb skeleton, and it suggests that it had these really long, kind of shorebird-like hind limbs. And so in the paper describing Asteriornis, we mentioned this. We mentioned that, it has these kind of potentially shorebird-like proportions. So maybe modern birds did evolve from a shorebird-like ancestor in terms of its ecology. They weren't the modern group that we call shorebirds today, but they could have had, a similar lifestyle. And, again, we don't have great fossils from this time period for most part, so we definitely would need a better record to confirm these ideas. But yeah, I think that idea is on the table. One final thing I'll mention is that this kind of parallels kind of the insectivore morphology in mammals, right? Um,
Yeah.
yeah, because we know that all modern mammals probably descended from a kind of shrew-like ancestor, and we actually do have fossil evidence of this, of Mesozoic mammals that looked a lot like shrews. Now, of course, this does not mean that shrews evolved into other mammals. They didn't. We know they didn't. Rather, all mammals came from an ancestor that probably, had an ecology very similar to a shrew. And in some of the living groups of mammals, they still retained this kind of shrew-like morphology, and with the true shrews being one of these, but there are others too. And so we might be seeing something similar going on here, where a shorebird-like ecology was ancestral to modern birds, but it was only retained in the true kind of charadriiforms. So yeah, interesting possibilities there. Do you have anything else to add about that?
No, but I think it's definitely funny that like this hypothesis, I guess, kind of went through like a full circle there.
Right. Yeah, yeah.
Shorebirds gave rise to other birds. Well, not really. Well, I mean, those early birds that gave rise to the crown group may have been shorebirds, but they just weren't shorebirds
Right,
proper.
right. Exactly, exactly. Alan Fiducia might have been right about that one.
Oh,
At
well,
least sort of. Yeah, in fact, we actually cite his paper in the Asteriornis paper for that. It is kind of the last reference we cite in the main text for that, kind of intentionally.
sure, sure.
Yeah, yeah. We kind of wanted to give him a shout out for for that. That's a reason. Yeah.
I wonder what that would mean then for. I know we talked about this a little bit like
Mm,
early on in the series, but like I wonder what that would mean for the survival of crown birds
mhm.
across the Cretaceous extinction event.
Right. Yeah, that's a good question, and I would say it seems pretty consistent with some of our ideas about it because, if these are shorebirds like kind of scavenging things off the beach or, looking for things hidden in the ground, they potentially would have been in a pretty good position to survive in the wake of the mass extinction because they're not directly dependent on like green vegetation. Um, Probably they could still live on a lot of things that had already accumulated in the ground and were still there for a long time and had not been depleted. Um, if some of them were able to scavenge from carcasses, that would have been good for them. Um, so yeah, I think it's kind of potentially very broad kind of diet that potentially a shore dwelling bird would have had. Um, seems pretty consistent with what we think might have helped crown birds survive the mass extinction.
Right. That's fascinating. Oh,
Yeah,
oh my gosh, this is completely off
yeah,
topic in a sense, but somebody made a video about the Cretaceous extinction event in a certain way.
yeah.
They kind of made like a hypothetical, like in real time scenario of what would happen today
Uh-huh.
if a Cretaceous sized asteroid hit the Gulf of Mexico
Wow.
and what that would do to the
Yeah,
planet.
yeah.
Oh my god, that's a haunting friggin'
Oh
video.
God.
'Cause, like, they did not skimp on details. They have all these little tiny charts throughout that talk about like, earthquakes, tsunamis, debris, the level of the sonic waves passing through the air.
Wow.
It's just to see that and then think about like what these animals went through
Right.
66 million years ago. It's just that puts it in a whole new perspective
Oh
for me.
God. Yeah. Sounds harrowing for sure. Like, yeah, I definitely hope we never have to like put that to the test in our lifetimes.
Oh, yes, certainly.
Yeah.
Here, here.
Yep. Yeah. So seems like by the skin of their teeth, well, they didn't have teeth. Crown birds made it through, and yeah, eventually we got all the wonderful diversity we have from those early shorebird like creatures potentially.
What a great diversity, too.
Yeah, indeed, indeed. So yeah, basically transitional shorebirds No, but also kind of, maybe.
Well, yes, but actually no.
All right, let's see what's next. Yep, next we have the preview. So, as we can see, the shorebirds have done, really well for themselves in these marine habitats and marine adjacent habitats. And I even said that, some of the auks can be considered some of the most marine dinosaurs ever, in terms of the amount of time they actually spend in the water. But the vast diversity of birds that spend their lives out at sea are actually members of a different group. And this group is sometimes called the core water birds and is a big assemblage, a very big, diverse assemblage of birds that have adapted to aquatic environments in pretty much any way you can imagine. And so it is to the core water bird group that we will turn to next. Next time we will tell their story.
Oh, how exciting. Some of my favorite birds, too.
Definitely, yeah, me too. There are some really cool creatures in this bunch, as always, but especially here. So, again, as usual, we would like to thank our friends for their contributions to this series, Henry and Alicia. And, if you want to keep up with our show, you can follow us on Twitter, Time and Clades, and follow us on our YouTube channel to, keep up with the videos directly. If you have questions, you can leave a comment or send us an email. And as usual, of course, I will include references and links to articles in the description. So, yeah, next time we'll go back to your series, isn't that right?
That's right. We're going to talk about Neanderthals and Denisovans and that whole collection of our closest relatives.
Awesome. That's a really interesting story. I look forward to it. Um, excellent, excellent. So, with that to look forward to, hope everybody, stay safe and take care.
Absolutely. Good. We'll see you later, everybody.
Mr. Darwin on the Beagle sailed the oceans and seas to South America and Tahiti and New Zealand, Maldives, to Australia and Tasmania, Keeling Island and St. Helena, to Ascension and Mauritius and Brazil de Verde and the Galapagos Islands. Mr. Darwin on the Beagle sailed away for 5 years. Mr. Darwin, on his journey, watched the plants, beasts, and birds. He drew pictures, gathered samples, kept a journal full of words. Looked at beetles, finches, mockingbirds, giant tortoises, flightless cormorants, studied daisies, prickly poppies, climbers, cactuses, cassava, coconut, and cress. He wondered where they came from, and he soon had ideas. Mr. Darwin, when he got home, wrote his new ideas down. But he didn't like to offend, so didn't share them around. Many years passed, Mr. Darwin got a letter from a Mr. Wallace. Now this young man had discovered just the same thing Mr. Darwin found aboard the Beagle. Mr. Wallace had the self-same idea. Mr. Darwin and Mr. Wallace formed a team for some time. Then Mr. Darwin wrote his big book in 1859 on the origin of species by natural selection. Everybody read the book. Everybody had an opinion. Some people praised it, others damned it. Mr. Darwin's big book. Mr. Matthew was a gardener when he read Darwin's book. He wrote a letter to the paper saying, just take a look at the book I wrote nearly 30 years ago. I had all the same ideas when Mr. Matthew and Mr. Wallace were forgotten over all the years, and now we just remember Mr. Darwin's big book. So now when you think about natural selection, do spare a thought for those forgotten too. Remember their names, just a brief recollection. Alfred Russel Wallace and Patrick Matthew.